The pillow plate heat exchangers and the tubular heat exchangers have a big difference. Just imagine that a tubular heat exchanger is round and the stream is linear. That means the core temperature stays the same because it never has the possibility to also go to the surface of the tube to touch the surface to transfer the energy. So that means you either need a lot more space, a lot more flow rate, or a lot more surface of the heat exchanger to provide the same energy. Okay? So if you use a stainless steel or a titanium plate heat exchanger, and titanium or stainless steel are not suitable anymore because you're using acidic solutions, you can use coatings, different coatings, for example FEP, PFA or others, just to have a block of a permeation and just making them suitable for the acidic solutions. If one plate is not enough, just because of the needed surface of the plate heat exchanger, you could have different multi-plates, so we call them multi-plates. So you have just one inlet and one outlet, and with a collector, and this collector is just, we're talking about physics, so the collector is just providing the flow in every, I missed the words, I'm sorry. So provides the words in every plate, provides the stream in every plate sufficiently. So how does it work? As I said, if you have just a tubular heat exchanger, the stream is linear. If we have a plate heat exchanger, the stream goes in. So please, if you see the colors, it's not the temperature. We are talking about the liquid stream in meters per second. So you see that here in this area the stream has to accelerate, and then it hits the first dot and it splits. It hits the next dots and splits again. And after that you have a, let's say, more or less current stream, but the chambers, sometimes the chambers are bigger and sometimes the chambers are smaller. That means that the liquid has to accelerate and decelerate. And this makes a very high turbulence, and every molecule touches the liquid, the surface of the heat exchanger for several times just to change the energy. So just for an example, that if you have a coil heat exchanger, the inlet temperature and the outlet temperature is just some degrees, yeah, or the change. But if you have a plate heat exchanger, the outlet temperature is nearly the liquid temperature and not the inlet temperature. Okay, so all of the temperature and all of the energy has been changed. We are talking about heat exchangers. Heat exchangers means we are changing heat so that all you cool with them, or you could cool with them. So where does this advantage come from? So the higher heat transfer coefficient is the big factor here. So you see that a coil heat exchanger has about 150 to 1400. Plate heat exchanger, they start at 1000 and go up to 4000. So if we take the formula in mind, so if we are calculating the power, you have the coefficient, which you have here, multiplied with the area and multiplied with the delta T. So if we have a higher K, so the transfer coefficient, means that we either could lower the delta T or the area. That means they either get smaller, or they also could, you also could work with lower temperatures. Of course, you need certain delta T for reaching the temperature, that's clear. So with 90, if you want to achieve 90 degrees, you cannot go with 93. Of course, you need a delta T from about at least 15 to 20. But with, for example, if you just have a heat pump which only provides 90, you could reach temperatures more easily, let's say. So that means that the heat exchangers save space. For a plant builder, this is quite interesting, because a plant builder then could maybe make the tanks a little bit smaller, or the customer has the advantage that he has a bigger production window. So we have customers who are using, who changed from coils to plate heat exchangers and now enlarge their production window and have a certain percentage more production. So the big advantage are, for example, the easy maintenance, quick cleaning. I will show you a video in some minutes where you see how easy they are to clean, because if you have a coil with a lot of rows, it is very hard to clean them, especially if you have an encrusting or sludgy solution where it is very hard to get in, because then you have a big clump rock. And I also have cleaned them, and this is not fun. So, and you save a lot of time in cleaning them, of course. So you also have a very high durability and reliability in the operation, individual design, and according customer demands. So what are we doing is, or let's say this way, you do not have to make all your calculations by yourself. So this is our job. So we just have a form. This needs about 5 minutes to fill out for you. And we make all the rest of the work. We will make the calculations. You will receive a 2D drawing. Check if the, let's say, rough size is fine. After that, if you say yes, they are good, you can get a 3D model which you directly could implement into your tank. So it is very easy to mount them and to handle them. You have a higher heat transfer coefficient. I already said we are a German manufacturer. Everything is made in Germany, and also the heat exchangers are manufactured with all the norms and the pressure directives. So I also want, so who of you has seen or is working with phosphating? Some of you? Nice, good. So these people who know how hard incrustations phosphating is making, even a manganese phosphating or a zinc phosphating, we have prepared a video for you. So this is a zinc phosphating, so even worse. And this phosphating is about 4 weeks old. So after 4 weeks, the customer has to clean it. And you can see here how it falls off. Usually, if you have a metallic plate heat exchanger or a metallic coil, you have to... the video is a little bit blocking. Okay, so you have seen that as well in the front and at the back, it just fell off. Yeah. Usually, if you have a stainless steel heat exchanger or a stainless steel coil, you need an extremely high amount of chemicals, or you have to smash on it with a hammer, and danger that something breaks down, you have to repair it, and it needs a huge amount of time to reassemble everything and so on. So the plate heat exchangers are a very big thing here. And we have talked about other solutions where you also could use the plate heat exchangers. For example, in the food industry, in the drinking industry, or in the chicken industry. So we have the chicken slaughtery where the chicken had to be cooled down after cooking them, after taking out the feathers. Also, of course, in the wire, copper wire. And here you can see just an example from this. So this was about 2.5 meters high. It is very small, but maybe you can see that this is a coil heat exchanger in an L shape. And it was about 2 meters or 2.5 meters long and 2.5 meters big. So this was one heat exchanger for one process. And we've substituted it with this size, and you see this is a pellet, just a Euro pellet. So how small they can get. Also, the fish industry is an extremely big market. Yeah. So this is very, very interesting. Cord, so making these cords. Here you can see a plate heat exchanger in a small machine with a cooler from a computer. In a baking, cake baking company, we had to cool down a cake after baking before they make the topping, otherwise the topping would run. And also in electrical cabinets. Also in spas where you need ice and so on. So the field is extremely wide and extremely big. But as I said, or as we are here mainly for the solutions for the metal surface finishing, there is no chemical which cannot be handled by plate heat exchangers. So, of course, we have a booth and a big team, so if you are interested, please come to our booth at C3. It looks like this, and with this, I want to thank you very much for your attention, and have a great day.
Thank you. A quick question, anyone?
Thank you, Mr. Christian, for a very important and interesting topic. We all know that the heat exchange is so important in plating industry also, and sometimes it is a limiting factor because you need to wait for a long time to achieve the temperature, either lower side or upper side. So thanks for a wonderful presentation. And
we welcome
Thank you very much for giving me a good chance to have a presentation here to the ISF Association today. And today I want to have a very simple and short presentation about the zinc-free coating technology. I thought that not telling too much information and giving a simple short idea would be better for you to understand these things, what I want to tell you today. So we we are a Korean company, Elbest GAT. We have been studied the water-based technology only for more than 50 years. So we only know the water-based technologies. So today, I want to tell you the water-based energy-saving zinc brake coating technology and some basic information about the zinc brake coatings. I know that some of you already know about the zinc brake coatings, and as I meet some guests at the booth, at our booth, some of customers don't have enough information about the zinc brake coatings yet. So I thought it would be better to tell you what is the zinc brake coating and what is the water-based zinc brake coating first. Yes, we made the paint. Actually, zinc brake coating is using a paint. You see the paint in the middle. In other areas, you use the paint for the car, on the wall, on the house, everywhere. And this is also paint. So you put something into this paint and you cure it by the oven or any hot sources. And then you will get finally that kind of the silver colored coated fasteners or some other metallic parts which need anti-corrosion properties, which you need protection from the corrosion. To make this paint, we use the water, actually, not the solvent. You may know the paint, the solvent paint and water-based paint. Solvent paint, you can smell very bad smells, and there is surely possible chances for the risk of the fire always. So, and also it is not good for your health, and there are many other reasons. Yeah, I know that this is the third day of the seminar, and for the first day and second day, there was also companies which explained to you about the zinc brake coating technologies. But I think some of you are still new to this, so I just added one simple presentation file here, the page here. So, zinc brake coating compared with zinc or zinc nickel electroplating or sometimes the hot dip galvanizing. This gives very good high performance of anti-corrosion properties. However, you only need very thin coating of this compared with hot dip galvanizing or sometimes compared with zinc brake coatings, the zinc electroplatings. So this zinc brake coating gives the anti-corrosion properties by 4 ways. Everybody knows that zinc gives the satisfied protection, and also you get the passivation. And zinc brake coating is consistent with the nano-sized flake of the zinc and the flake of the aluminum. Both flakes are, layered very tightly, so it makes a kind of barrier. So it blocks the attack of the humidity into the metal surfaces. So it gives the very effect. And also, everybody knows that zinc have the self-healing effect also. Those 4 are key effect of the zinc brake coatings. Yes, metal surface, sacrifice protection, and passivation. Yeah, that powder is the shape of the layer of the zinc and aluminum brakes layers. we use the magnifier and get the butter in the middle. So I told you that this is paint, and for the zinc-free coating field, we also have two choices. The one is the solvent-based zinc-free coatings, and another one is the water-based zinc-free coatings. So if you want to start this coating here in India in your field, you will meet some the companies which provide the solvent-based paint, and also you will meet some companies which is supplying you the water-based paint only, like us. So everybody knows that the solvent-based paint, we think about the VOC issues and the smells and the fire risks and those of issues. So we all know that water is much better for the eco-friendly regions and for yourself also. So today I want to emphasize about the water-based. Yes, why we should switch to water-based paint. So many countries and governments are now making guidelines or rules to make the people to use more eco-friendly chemicals. And what I know that in China, some area, they strictly only asking the people to switch to the water-based paint, that kind of things. As because of VOCs, and which makes the ozones, and will finally give us the issue of the global warming issues. So we have to change it to the water-based from the solvent-based. So our product for the zinc-free coating, we call it Geo Coat. Everybody knows that Geo means some of the eco-friendly things. So we are in the market. There are some water-based zinc-free coatings exist, but we are a little different from the other companies. You know that the solvent-based zinc-free coatings normally being cured at 250 degrees around. And however, the water-based zinc-free coatings need about 350 degrees. 100 degrees is more higher temperature. It is eco-friendly. However, there is some minus point, a weak point for the water-based. So we wish to make a new product of water-based zinc-free coating, which can be cured at almost same temperature with the solvent-based paint at 250 degrees. So compared with other water-based coating, we call this as the energy saving also, eco-friendly and energy saving. Chrome-free is just basic for these days. Zinc-free coating technology started more than almost 50 years ago, surely. At that time, the companies used the chromes, the trivalent chrome, together with zinc and aluminum to give the very high performance of anti-corrosion. However, we all know that chrome should be removed from the formulation. So more than 15 to 10 years ago, all the companies, major companies, start to supply the chrome-free version of the zinc-free coatings. Possibly in the market still, some customers and some companies are still supplying the chrome-contained paint, but we should change also. So our version of the low temperature curing geocoat technology is we focus on making the VOC less than 10%. Water-based paint also contains very, very small amount of solvent inside, technically. However, we focused on how to minimize it, and we made it less than 10%. And we try to make it to be cured at 250 degree. And also, we also wish to make a minimum 1,000 hours of neutral salt spray test to pass it. The test, as the market requires, is becoming more high targets. We are continuously doing R&D jobs on this, so we will try to make it the temperature even lower than that. And that is our target every year. This is some theoretical thing of how we made the normal 350 degree become to the 250 degree. In general, in the market, some other water-based zinc-free coating makers uses the sealant monomer, just the normal sealant monomer, to make the binder and coating. However, as we only study the water-based technology, we have own technology to make the sealant oligomer by adding the epoxy. So we made a special epoxy sealant oligomer. So by making the oligomer, it gives a chance to make the cross-linking of the binders more faster and at a more lower temperature. That was the key for us to making it be a low curing version of the zinc flakes. That is epoxy sealant and water and catalyst, and that makes the condensation and polymerization, and after that it cross-links to make the coating finally. We say the ER or the solid contents residues after the evaporation. So just wanted to compare with the conventional product. You can see to make this final ER number 18%, 18% the geocoat is ours, and the second and third is the other product. There the ER rate is 16% and 13%, and you need about 30 to 40 minutes to get the target, the ER rate. And you see the blue line, we are near the 2070 degree around, and less than that. However, the other two need the below is the temperature, need the minimum 330 degree of temperature to get the solid content finally. So we just wanted to mention the name of the others, but there are many paint suppliers. The one from Japan is also water-based, and we are from Korea, and we have the USA, Germany, and other countries. So our temperature is almost same as the solvent-based, 250. And we use the special sealant oligomer, and others use the sealant and sealant organic binders. And we should focus on the VOC rate. We are less than 10%, and the water-based 20% around, and almost the solvent-based contains solvents, so it is almost 50%. For the SST performance, everybody gives the good result. I show you this photo because I wish to tell you the next slide. This is the pine tree of Korea. I don't know there is a pine tree in India or not, but so I just wanted to show you the photo of pine tree. This is the forest of pine tree in Korea, and with this pine tree, our ancestors made a palace. but the Korean palaces mainly use those wood to make the buildings. So our ancestors had very, they wanted to make a good forest. So VOC and CO2 gas emission and energy saving, those are, I want to explain to you by comparing with the requirement of the pine trees. As I said you, the CO2 gas emission quantity, and I put the number of the pine trees. Pine trees to offset the CO2 gas emission. I got the numbers from the Korean government statistics. So by making the low temperature of curing, you can also save the amount of the CO2 gas emission like that. And that means we need only some small number of the pine trees for that. So yes, also the similar information. So finally, I want to show you this final one already. I think with this low temperature water-based coating, we are giving 1200,000 hours SST. That number, the coating weight means the coating thickness. So if you give a little high coating weight, then yes, so it's related with the SST. So you can get enough SST. Finally, one more. Recently, with Hyundai Motors and Kia Motors in Korea, we are doing the co-op for changing the high temperature zinc brake coating with this low temperature curing zinc brake coating. First start was the brake rotors. By the curing at the 350, there is a possibility of the reformation of the discs, and it caused some noise and that shaking or trembling, that thing. So there was some, the complaint from the customers. So Hyundai Motors asked us to try the low temperature curing version of zinc brake. So we did it, and there was no change of the forming of the discs, and we are doing those jobs together with them. Yeah, that's it. That's the final. Thank you.
Thank you. Any questions, anyone? Thank you. Please accept a little felicitation.
Kevin, for giving a nice talk on zinc flake. And zinc flake technology is peaking now because of it is greener approach of the coating and having very robust corrosion resistance property.
We welcome Mr. S. Chakravarti and Mr. Kishan Pandey for presenting on the engineering and chemical solution to support plating and plastics.
So Mr. Chakravarti need not any introduction. He is working last 30 years in the electroplating industry and has served this industry in many capacity in many technology. Please, Chakravarti.
Good morning. It's nice to be here today morning, and especially when the session is being chaired by my colleagues. And I welcome all of you to the discussion today. What we are going to speak about the chemical and engineering solutions in POP, and it will be presented by myself and my colleague, Mr. Kshitish Pandey. Well, I'll quickly run through we all of us, we are aware of it, what is ABS, that is acrylonitrile, butadiene and styrene tar polymer. And these are basically used in many usage, particularly for reducing the weights. But of course, this is a plastic, so for making its electroplated coating, there are a lot of engineering and chemical solutions are involved. So moving forward, I divided into the categories. Molding, very important, because the part shape is being done through the molding process, and there are a lot of technologies and there are a lot of engineering aspects are there to take care of it. For example, some of the things I can mention over here, like the nominal thickness of the wall should not be more than 3.8 mm. I think it's better that. Okay. So, if the wall thickness are not uniform, the shapes of the plastic components are not. Sorry. It will not be uniform, and there could design some. It can yield some stresses, and thereby creating some issues. Jigging, very, very important, and particularly the contacts with respect to the dimension of the substrates. For example, a part with 2.32 dm square dm up to 0, I think it should be one contact, or if it is, let us say, 9 dm square, it can as high as more than 12 contacts, because we all know from the metal, and if you have to go for the plastic plating, so at least 25% of the contact area is needed. There are a lot of activation steps are involved, and we'll go through one by one in the next slide. And thereafter some electrochemical processes where we plate copper, nickel, chrome. Particularly, copper acts as a very good ductile coating, so that if there is any stress or in the substrates, copper can take care of it. Otherwise, there could be a thermal cycle failures and all these things happen. Okay. Starts with the chrome-based etching process, where it actually removes the butadiene from the substrates and increases the surface area and make the surface more hydrophilic, loving. And we get a lot of micro pores, and it has to be very, very uniform, so that we can just like it presses press button effect, like all the the keyboards, and then all the it's one after the other. So you can see the surface morphology of the etched surface, but nevertheless it generates a lot of trivalent chrome in the process, and if the trivalent chrome goes more than 30 grams per liter, then it creates a problem. So then again the engineering solution comes in the foray. So there are a couple of processes, but most widely used process to remove the trivalent chrome is the porous pot method. So solution can be transferred to a second tank, wherein through electrolysis we can remove the CR3 in the porous pot solutions, and then porous pot solution, whatever is there, we can throw it out. Now, for example, there is some calculations are required, so it is given over here. So by and large, let us say 100 square meter of ABS leads to the generation of around 325 grams of CR3, and by these calculations we would need 4 porous pots and for 1 hour dummy to remove that 325. So what I mean to say, if we plate, let us say 100 square meter of ABS, and if we can have a porous pot purification system with the 4 porous pot, and we will be able to remove the CR3. So as a result of which the solution can be maintained in a more healthier situation. Well, there are a lot of activities are there to generate chrome-free aging process. We launched it long back, but there are some processes, there were some more precipitations, and then that was the issue at that time. Now also there are different activities are in progress, and at this moment some propositions is being put forward based on manganese 3 in situ generations, and thereafter when the it oxidizes and it forms Mn2, and then this Mn2 will be electrochemically regenerated back to Mn3, and that's why this process is now appears to be workable. But there are a lot of challenges are in in this process, particularly the jig coating, sometime some sort of an higher precipitation, all these things are happening. But with this proposition, it appears that we will be having very soon the proper proposition for the chrome-free etching process. Well, there are different, next process is the activation, very, very important steps with palladium and tin based process, wherein the palladium tin colloids, particularly the particle size matters it matters a lot, and the particle size, if it is smaller, so we get a better coverage, and so we can have less voids. For example, you can see these pores which has been created in the previous steps in the activation, the etching process, and in the etching there are a lot of the palladium tin colloids molecules get absorbed, and this is the activation site for the subsequent coatings. And in this particular process, the palladium is surrounded by the tin molecules, and the more or less the ratio remains 1:3, and which in the subsequent acceleration process gets tin gets subsequent to some extent gets removed, and making this substance more for the next step of the electrolysis or other deposition. Well, this is the next step is the acceleration. And this basically accelerator, what it does, it removes partially the tin. As I told you earlier that in the activation process, the tin and palladium, the ratio is 3:1. Now here what it means is that it removes a little bit of tin, making it to 1:1. So you can see it over there, and some of the process parts after aging, and then also after the acceleration process. And there are two type of processes are available. One is with the fluoride-based chemistry with the liquid type, and some of the processes are with the solid version, which is nitrate-free and also fluoride-free. Next process in this pre-treatment segment is the electrolysis nickel, and there are two type of processes are available: sulfate-based system and chloride-based system. Now it is both the processes are very, very stable, and the path life is enormous, so absolutely no worry. It can be somebody can have even through the dosing pump, somebody can dose these chemicals, very, very stable. Chloride-based system is producing little bit of brighter finish, but it gives the initial conductive coating so that in subsequent electroplating can take place. We can see some of the process photographs, and wherein we have the electrolysis nickel on the parts after the activation. This is the surface topography with the first one is the basic substrate, and it is after aging, then after activation, and after electrolysis nickel. We can see that after electrolysis nickel we have the globular morphology, and with some grain which is clearly visible, and with, as I told you, with the chloride base we can get a much more brighter finish with a smaller grain. Well, we talked about electrolysis nickel. So there are new processes are also available called direct metallization. So here what happens that after the activation stage, copper gets exchanged with the tin gets exchanged with the copper and forming a layer of copper which is conducting, and thereafter we can go to the electrochemical processes. What we are introducing here is that the higher thickness direct metallization process. Now here you can see that the component on the left side, this is after electrolysis nickel, and component on the right side, it is with copperish color loop, and that is the direct, this CU exchange copper exchange process. Now we can see that the color of the components is pinkish, so it itself justifies that the thickness of the copper is higher. So approximately we have analyzed around 700 nanometer is the thickness. So if the thickness of copper is high, so more copper on the substrate, we'll have more conductivity, so we can plate even the bigger components with a relatively good way. So we have tested the in comparison to electrolysis nickel and the copper exchange process, we have analyzed the resistance, and you can see it that 0.1 to 0.7. So obviously 1 and 7 the resistance will be higher. Now you can see it here, 1 to 7 with the electrolysis nickel is approximately 20.9, whereas the DMS systems with our process, it is approximately 0.8. So, and virtually in all the 0.1 to 7, 1 to 2, and everything, it is more or less similar. So what we are trying to say that with the higher amount of copper on the substrates, we are getting better conductivity on the substrate. So some of the addition tests is being done after coating. So it is passing, so there is no left out material on the tape, so there is no problem. So these are all the subsequent processes like acid copper, nickel, and chrome. So I will take you to some of the components processed at different stages. Well, now we all know that we have been using the hexavalent chrome processes, and there are a lot of drives to go for the trivalent processes. So these are the some of the processes, like with first one is the chloride sulfate mix based process, and with where we get a nearly good L value of approximately 79. Then we have the other one is the black, that's graphite color, not dark black, but it is, I've already, some of the parts are shown over here. We get an L value approximately 55 to 60. And another one which we have recently developed where the L value is for around 38, means approximately 40. So when the L value goes lower, we get a more darker appearance. So you can see the differences. But this trivalent chrome chemistries is not impurity tolerant, and like hex chrome chemistry. So there we have to remove the incoming impurities, whatever coming in the solutions, and to get the desired color or desired system performance. So we have introduced the ion exchange purification system. Now you imagine that what are the impurities coming? Copper, nickel, etc. So these are cations, and chrome is also cation here with the trivalent, Cr3. So if we use normal ion exchange, cation exchange, what it will happen is it will remove all the involved cations. So that it will create a problem in the chrome plating process as well, because it can remove the chrome also. So we use a selectively, selective affinity resins, which is chelating type of resin, which from the system it takes first copper, then nickel, and when the solution is totally free, then very minute affinity it has got with the chrome. So in this process, if we run the system with this ion exchange process, it will not remove Cr3, which is very, very important, but it will remove copper, it will remove nickel, so make the system is relatively impurity free, so that we can get a desired color, and also the system maintain the system efficiency. The last process, very, very important, because we all know that on the jig contact points there are a lot of deposition takes place copper, nickel, chrome. And on the jig contact points, if we have the accumulation of the metal deposit and the same deposit comes for the second time, it can create some of the issues, particularly burn off and everything. So it is very important to remove this. There are single station jig, single process, one step process is available wherein the chrome, nickel and copper all can be removed electrochemically, and subsequently we can get a jig contact area relatively problem, no coating as such, so that jig can be reused. With this, I request Mr. Sitish to take us small in the another some on the engineering side as well.
Thank you, Chakrabarti Sahab. Thank you very much for an enlightening session. So good morning, everybody. My name is Kshitij Pandey, and I look after the sales and marketing for the engineering business of Grauer & Ware, where we offer turnkey solutions, process plants for plant and machinery for conducting your mission-critical plating applications. I think Mr. Chakrabarti has summed up most of the things. It's just a matter of being repetitive. But at the risk of being repetitive, I'll take you or walk you through some of the critical elements when we design plants. And before I get there, just to give you a background, as most of you may be aware, Grauer & Ware has an engineering business which focuses on offering turnkey plants and systems for your plating applications. So we are a one-stop shop solution for your chemicals, plants and effluent treatment. I understand my colleague Parag will speak after an hour on the effluent treatment capabilities for Grauer & Ware. But I'll just walk you through one particular slide of Grauer & Ware and also tell you why or what is critical when you're looking at your plant from an engineering perspective or when you're designing the plant. So there are two critical elements, and there may be more. I mean, just for the sake of trying to keep it compress the entire schedule because it's a long topic or a very intense topic. There are two critical elements when you're designing a plant. Of course, you are looking at the design part of it and you're looking at the process and automation part of it. And when these two start talking to each other and making sense, you have a complete holistic solution, a seamless, flawless offering. So when you're looking at the design, you start from the elements or the elementary situation where you look at the sequence of your operations, the process flow. And while it may sound as a no-brainer or something which is taken for granted or understood, it's something which is very, very elementary to give you the right or optimized offering or solution. So you start from a layout where you optimize the sequence, you decide, discuss together and arrive at an optimal situation where you say which process comes before what and what happens next. For example, derusting, post-degreasing. Now, somebody may say that's a no-brainer, yeah, we know that. Yeah, but these are things that need to be planned, discussed and spoken about. Process parameters. Often this is, again, something very basic. So everybody says, yeah, we know we need to have the best of agitation, optimized, consistent. Temperatures within the bath have to be within a narrow bandwidth, controlled. But these are very critical. How do you do that? How do you execute it? How do you monitor it? And how do you control it? Jigging and anode positioning. Like Mr. Chakrabarti shared, these are plastic components. You need to ensure that the jigging is done at an optimum design pattern. The only reason being you don't want to induce unwanted stresses or have uneven coating. It starts from there. If your jigging is not consistent, it can directly impact your surface coating and surface plating. Energy efficiency is the buzzword, and not now, it's been there for some time now. But what do you really mean by energy efficiency, and what are the options available in the market today? We all know that our process may require heating, cooling and other aspects of utilities. So what energy efficient technologies do we use? If we are looking at a bath temperature of about 60 to 70 degrees, can we go for a heat pump instead of the conventional hot water generators or electric heaters, which are CFC free? Again, from the process automation part of it, look at the process design, the moldability. how are you going to look after the etch generation process? Mr. Chakrabarti already spoke about that. Purification. So while on one hand we are running the plant, we are doing everything right, how frequently are we making sure that we are getting rid of the impurities? And how are we doing that? And how are we monitoring that? So how do you monitor when your solutions need purification? And how do you actually execute that online? Flexibility, especially in plating on plastic where you have different types of finish requirements. How flexible is your solution? How many components can it handle? How many processes, how many sequences can it cater to? And in what manner? And then online treatment. Again, I think Mr. Chakrabarti spoke about it at the last moment. Online stripping. Because again, if you don't do the online stripping of jigs properly, you may end up with contamination, you may end up with poor plating quality. So these, as I shared initially, sound very basic, seem very basic, but that's where the entire discussion starts and is very important, because this will make or break your final solution. So that's it from us, friends. Thank you very much for your time and attention. Appreciate it. Any questions, we are here to answer, myself or Mr. Chakrabarti. Please let us know. Thank you.
Thank you, sir, for your nice presentation. Chakrabarti, sir, please come. I request to Dr. Saab or Arprat ji ko, please felicitate him.
Thank you, Chakrabarti sir and Mr. Chiti, talking about the engineering and chemical aspects of POP. I would like to say that only good chemical cannot give you a very good plating. So you need engineering solution also and some other operating parameters. So I would like to request him to take more presentation on these aspects also from the next time. Thank you very much.
Sir, thank you very much for the chairing these sessions. Please, Anand sir, felicitate him. Chakrabarti sir, please come. Please.
Friends, due to want of time and today being the last day, we are skipping the tea break. Tea is kept out there if anyone wants. I'd now like to invite Dr. Patodia to chair. I'm sorry, give us 2 minutes. Please welcome Dr. Patodia on the dais.
I welcome Ms. Pilar. She has BSc, MSc in Metallic Engineering in 2014 and 2016 respectively. He holds PhD program at same university. She has 9 years of experience in the aluminum surface treatment industries. Currently, she is working as the global technology leaders for LMS group at McDermott Anthon Industry Solutions. She has had one laboratory experience, X-ray, Raman spectroscopy. I welcome Dr. Pilar.
Hello everyone, I'm Pinar. Today I would like to give you some information how we should select sealing in our procedure. So LMS Light Metal Solution is a dedicated group in McDermott Anthon Industrial Solution. We are a dedicated team for the light metals chemical solutions. When we're talking about the light metal, we include aluminum, magnesium, and titanium. So as McDermott Anthon, we have different product brands and groups required to the different industries. For example, we have Castalox for the cast aluminization, oxidide, iridide, and alumal product groups. So light metal solution has two different R&D sites. One of them is in Turkey, the other one is here in Bangalore, India. And because of the nature of aluminum, we need to protect it against the environment. We cannot use aluminum as it is. So we can apply anodizing, or we need to apply some conversion coating plus painting. So today we will more focus on the anodizing process and more in detail sealing. Anodizing is really well-known procedure established around beginning of 90s, actually 1911. So normally we start with the cleaning, any kind of pre-treatment, and anodizing itself produce or perform in acidic solution. It can be sulfuric acid, oxalic acid, or any kind of acid. Most commonly used one is sulfuric acid. Then optionally we can continue with any kind of coloring, electrocoloring, organic dye, or interference coloring. And the last step of the procedure is sealing, which is essential for the corrosion protection, UV resistance, and final performance. In here, we would like to underline several parameters. So as you can see here, all of the final product's performance related to your oxide layer structure. I mean, the thickness, the wear resistance, colorability, corrosion resistance, wear resistance, all of them is a function of the oxide layer structure. If you have more homogeneous and coherent oxide layer, generally we end up with the better performance. So for that purpose, we generally using the fire analogy. We really like it. So for the creating the best possible anodic oxide layer, we need to obtain, or we need to use the right substrate, we need to have right electrolyte, and we need to select the right parameters. And finally, if we can select all of these three parameters, we can create quality and sustainable service. The sealing, as we told, this is the last step of the anodizing. So if you think like it's a puzzle, so every step is important. So we would like to underline the importance of the alloying element. Because if you're working with 2,000, 7,000, 6,000, the behavior of these wrought alloys change in between. So 2,000 has loss of copper, which needs special pre-treatment. And electrocoloring or any kind of coloring is another important parameter, because one of the beautiful beautiful feature of the undercoxide layer, it can be colored by using different technologies. And for the fulfill the industrial's requirements, you need to apply correct sealing. So if you compare the unsealed oxide layer and sealed oxide layer, there is a huge differences. So obviously, the anodic oxide layer itself creates the corrosion protection. But as you can see in this picture, we have some weak spot, which are the pore bottoms. So generally, we are creating 10 to 50 micron of oxide layer, but still, the pore walls are high thickness, but pore bottoms have the lowest thickness, which is normally 5 to 10 nanometer. So because of that, we need to close that pores by using sealing. That's how we get the full corrosion protection, UV resistance, and we can plug the coloring ingredients. It can be salt, it can be organic dye, thanks to the sealing. And aluminum currently using in various applications, various industries. One of the biggest industry is construction or the architectural. As you can see, you can find aluminum profiles and aluminum parts all over the house, which generally we are looking for the long life and decorative appearance. So when we are talking about the architectural application, we are selecting our ceilings, or we need to design our procedure according to these two major requirements. But if we are talking about the automotive industry, then the requirements are totally different. In this time, we are not only focusing on the decorative application or long life, but we need wear resistance, some scratch resistance, hardness, UV resistance, and even alkaline resistance. And this time, obviously, the things get a bit more complicated or tricky, because sometimes also we need to end up with some electrical features, which is not really possible with the oxidation. In this situation, we're generally using passivization. So we underline the importance of the sealing and the general structure of the oxidation procedure, but how we need to select the right sealing. So there is several questions. You need to consider several questions and several parameters. So you need to aware of your line capabilities. You need to know environmental regulations, and also we need to understand the final requirements. As we spoke, we need to know if it's architectural application, it is purely decorative. We need to wear resistance, we need to some UV resistance. So according to these requirements, we can select the right sealing. So in industry, majorly we have three different sealing types: hot seal, cold seal, and mid-temperature seal. So hot seal is the oldest one, but there is some limitation. I will give more details. And also we have cold seal, which is faster one, easiest one. It creates a really corrosion protective surface. And we have mid-temperature seal. Generally they are metallic based, and they really compatible with the organic dyes. So if we look into the details, as you can see here, the treatment time of the three different sealing are different. So the major differences is the treatment temperature and treatment timing. So the fastest one is the cold seal, the slowest one hot seal. But obviously, all of them come with cons and pros. So if you look at the hot seal, this is the more conventional way. So generally, with the using hot seal, we need to spend 3 minutes per micron sealing time, which means if you have 10 micron, it will take 30 minutes, which is sometimes can be problematic for the production line. But the good thing about the hot seal itself creates a transparent yellowish color, which is very common and well known in the industry. So maybe your customer looking for such a tint. And the other one is nickel fluoride based sealing. So this is the fastest one. The ADT, all of the quality tests will be superior when we compare the hot seal. But obviously it contains some nickel, and because of that, if you not have some solution for it, then you can end up with the green tint, which is totally different from the hot seal. And as you can see in here, we have different options as McDermott Anton industrial solution. I would like to underline a two-component system because this is really beneficial to control the bad concentration. So normally nickel fluoride-based sealants, we can use single-component chemicals, but then the consumption ratio of the nickel and fluoride is not really balanced. So when you try to adjust the concentration, you have some problem. You need to add the nickel, but also if you're using single component, you are increasing the fluoride, which can be problematic for the further applications. So when you're using two component chemicals, you can adjust the nickel and fluoride components separately, which give you consistent and repeatable results. And the other one is the nickel-based mid-temperature seal. We have different options in McDermott Anton industrial solution. As you can see here, it can be nickel-based, it can be magnesium-based, or even it can be organic-based mid-temperature seal. So these seals are performed between the 80 to 85 centigrade Celsius, so it's generally beneficial for the cold environment. So again, we need to ask several questions. First question, do we really need sealing? Actually, according to my presentation, yes, you need. But there is only one exception. If the part's gonna wear against the steering or wear, if the wear resistance is the major properties of the oxide layer, then we don't need any seal. But except that, any kind of application, we have to apply any kind of sealing. And the other question, as we discussed, we need to be aware of our sealing, our line capabilities. Do we have, what kind of water? Is it hard? It contains phosphate, it contains silicate. How many seal tanks I have? Because according to your capabilities, sealing can be the bottleneck in your production. So this is the quality test that can be applicable for the oxide layer. I got this from the Colonaut website. So, and all of the dark greens directly measure the sealing properties. The light green ones measure the oxide layer and other process steps plus sealing. The only thing regardless to the sealing is thickness. But except that, almost all of the quality tests is an indicator of the sealing performance. But maybe I need to give you a bit more overview why our presentation name is the Improve Your Failing by Sealing, because there is an ultimate test. In our laboratory or in the industry, you can understand the sealing quality by touching. So with the thickness, if it's smooth, then it means you have a real good sealing. If it's sticky, then you mean something go wrong during the sealing stage. So it's a really practical one, and generally 98% accurate. And I would like to give you three major challenges. The first one is the color compatibility. The other one is controlling the sealing rate, and the last one is alkaline resistance. So for the color compatibility, as we discussed, hot seal creates yellow tint, cold seal, if you're not taking care of, it's green. So it's felt like some kind of filter. So your outer layer is the sealing, and according to your sealing, you can end up with different reflectance, different colors, and then if you're trying to matching any kind of the reference samples, it can be tricky. So here you can see black samples produced by using the same process but different sealing, and because of the sealing type, the colors are not perceived similar. And also, when we are dealing with the organic dye, then we have a bleeding problem. For that purpose, we need to use or we need to select the right sealing. Generally, for that purpose, nickel acetate-based sealings are beneficial. But with the nickel-based mid-temperature seal, we need to be careful of the sealing rate, because if we are not controlling the sealing rate, then we can end up with the over-sealing, which create a yellowish, greenish smut on the surface, which brings extra work to clean the surface. So for that purpose, as you can see here, with different timing, we check all of our sealing rates or the speed. As you can see, by selecting the right sealing chemistry, you can prevent any kind of the sealing, over-sealing smut formation, but also you can create a corrosion-resistive surface. And the other problem is the alkaline resistance. So normally under the oxide layer, the underoxide layer only coherent or stable between the pH 4 to 8, which is not bring us to alkaline or acid resistance. So for that reason, we need to use a special sealing system. So we are defining different sealing system over here. And this is the different sealings, pH 13, pH resistance. As you can see, if we are using regular sealing systems like cold seal, hot seal, or mid-temperature seal, even the combination of those three, we couldn't really pass the automotive industry's pH 13 requirement, which is currently super-critical for above belt or below belt application. But by using the oxide S68LF and the S130 pH chemical, we can accomplish the pH 13 resistance. So overall, please don't forget to ask this important question. Do you need sealing? Why you need sealing? What is your quality parameters? What you need to fulfill? And then if you have electrocoloring, if you have organic dye, then please consider this one. And also not forget your line capabilities, water, environment, how many tanks you have. Is the heating expensive or not? So when you consider all of those questions, the repeatable and quality results are guaranteed. Thank you.
Thanks, Dr. Ms. Pina. She has given very interesting method of sealing after anodizing, because we are using aluminum after MS, second highest metals, and we are not, we may be using lot of anodizing articles, but not sealing well. From McDermott and Thorns Industries solution. Give clapping to Ms. Pina. Hello, I welcome Mr. Pascal and Dr. Venkat Sundaram. Topic. One. So, coach. Introduction. Okay. Introduction. He is sales manager at
He's the sales manager at CVEC and the mechanical engineer with 15 years of experience. Please welcome him.
Thank you. So yes, as already explained, I'm the sales manager of CVEC, coming from France. Maybe you can hear it a little bit. And we are represented here in India by a company GTS. It was founded by Dr. Sundaram Venkatesh here. And they are located nearby in Gurgaon. So, a few words about CVEC. First, we are a French and German company. We have 4 production sites in Europe and 6 subsidiaries, sales subsidiaries that sell directly our products. And all around the world we are represented in 45 countries by resellers. These are the key figures of CVEC. So we are 200 people. Our global turnover is 14 million euros. And we do invest a lot in R&D, almost 5% of our global turnover. And for the last 3 previous years, we have a continuous growth of annual rate 15% roughly. And this is a 100% private company. So, if we speak about our satin nickel, this finish is really appreciated by designer because it gives to the part a lustrous aspect. This gives a noble look. And by construction, this is glare-free because you will not have a direct reflection of the light. It will be a direct reflection, giving this special aspect. And some interesting thing is hardly shows fingerprints. So this is something interesting. Well, we can find it nowadays almost everywhere, especially inside our car. Also furniture, faucets, it's widespread now. So here is a microscope view of satin nickel structure. As we can see, it's not smooth at all, it's totally rough. And it is created by emulsions that we pour into the electrolyte. This emulsion will create, locally we will create some droplets that will inhibit locally at a certain point the plating, and we will create this specific structure. But there is a limitation with this system. It's that these small droplets during the time will gather and will create bigger ones. So as you can imagine, we will change the structure of the layer by having bigger droplets. We will have bigger inhibits points, and it will change the aspect of the part. So we are in fact limited. The period of application of the process is limited. We can consider roughly between 8 to 12 hours. So in reality nowadays, lots of companies are using this process discontinuously. How can we explain this? First of all, it's because lots of them don't know that such a system exists. And it's true that this is a very specific process, totally different from classical ones from copper or bright nickel. And we do know some customers who start with very low production. They only have one shift, and then when the production increases, they are doing exactly the same way. They are doing every 8 hours or 12 hours, they clean it totally, not thinking about having another solution. We have to keep in mind that this finish is really demanding, and every little failure into the process will create a high rejection rate. So, how can we extend the operation time? If we consider that we have our electrolyte bath, 100% of the volume, we will pump only one portion of this volume. We will push it into a specific filter, which is already pre-coated. This filter will remove, let's say, the old additive, and we will replenish new additive thanks to dosing system to guarantee that, but of course it will be in correlation with the quantity of liquid you will filter, not to have an excess or lack of products that will create different aspects. So we have designed for this special purpose our system called PBNA. This is a combination of only high quality components, and it's also proven filter units. These are the main components of this system. So we do have first a magnetic pump that will pump the liquid from the tank. We'll push it to a filter chamber. This is the main filter. This filter chamber is equipped with discs and papers. We will pre-coat it thanks to the pre-coating tank. We will add filter rates and activated carbon. And to be sure that no particles will reach the tank, we will add what we call a police filter with cartridges that will stop each particles. This device is delivered onto a frame. It's a skid that is ready to work. And you also have onto the left the dosing tank, dosing units, and the touchscreen. So, how to lift the technical lock? We see this is a high demanding process. So first of all, as we have previously seen, we need to have a clear installed pipeline. All the valves are easy to handle. First of all, this is something really important. And the valve will be 100% open or 100% closed, nothing in between to avoid any problem. We also have to need electronic surveillance because the flow rate must be controlled with a high precision in less than 1%, 0.5% in reality. And we also have to be really precise regarding the replenishment of additives, the metering pump. So we control it too. So the operation mode is separated into 5 main modes. So of course, first of all, you have to prepare the filter, you have to prepare the aggregate. So we will pour some additives, some filter heads and activated carbon into the pre-coating tank to prepare the filter. Then you have to add to the bath the emulsion, and you need to mix it with the electrolytes. So the pump will help for that. And then we have seen that at the beginning, coagulation does not operate, so you can work with no filtration, not to extract too much additive. Then you have the continuous use, so in that situation we will have the filtration, of course, and we will also automatically add the additive. And once per week, or depending on your production, one day every 2 weeks, we will have to make the maintenance of the system. We need to remove filter head and activated carbon to clean it and restart again. We have 3 different systems, from the most simple to the fully automatic one. As you can see, it's analog and SPS and SPS automatic. So here is a table to summarize all the features and characteristics. So with the analog system, we will have, of course, the filtration, the pump to circulate the liquid, but we are limited by the number of dosing tanks. We can have only 2 tanks. With the SPS, we can see that we can manage up to 99 colors. So we have, of course, monitoring of the dosing pump, plus password protection. We can also manage up to 5 storage tanks. and we have remove, servicing, dry run protection, all this type of options. Then we have the fully automatic system. In that case, everything will be controlled by the PLC. We will have automatic pneumatic valves. We will have everything guided pre-cutting. And you see we also have a larger screen, 15 inches, to be user-friendly. 3 different sizes are available, depending, of course, on the size of your production tank. From the 250 for small bath up to 575 for very big bath up to 14,000 liters. Each products are available in 20 or 30 inches high to increase the filtration capacity. So let's see more in detail the interface of this fully automatic device. So this is the screen. So something important is that for each operator we can create a password just to be sure that no one will change everything at the same time. You will have everything under control, and if some parameters are changed, you know where and by who. This is something important to follow the process. Here there is the overview. You have clearly identified all the main components, all the valves and filters, and even if it's a fully automatic system, you can take the control of each component. Here there is some close and open button. You just can take the control and use it manually. So the advantage of the system is you will have pop-up to guide your operators. So the machine will tell to the operator what to do. No need to have specific skills for that. For instance, this is the first phase to fill the additive into the pre-cut tank. So you will have, it says, please add some filter heads and activated carbon. When it's done, click and go to the next step. So there is no mistakes, less risk of mistakes. Here, as previously seen, we can manage up to 99 different colors. So the advantage is that you can give a name for each of your customer. It will be very easy to manage during the time. And as you can see, everything will be automatic, of course. And once it's filled, it's always retrievable. Easy to manage for the operator. Just to have a view more in details about the additive, we have, of course, the dosing rate management. You can see the flow we want to put, 0.45 millimeters per liter in this typical example, and then how many products we will use, 1 or 2 different names. So what's important, if ever you stop the automatic mode, before restarting, the system will automatically generate a checklist, as you can see here, to be sure that before you restart, everything is under control. So you have no excuse, and you can see you will for sure increase the awareness of the operator. Once all the points are checked and done, you can move to the next step and restart the automatic system mode. So this is the overview. As you can see, it's not too complicated. We don't show too much information, to be clear. You can see the status of all the different components here onto the scheme. And we show the speed of the pump, set points of the pump, and we have what is the real flow measurement. You know exactly which color is working on, and you have different set point value. If you have several units to connect together, it's not a problem, we can do it. We can link also the PBNA system to your process data, and you can have directly the rejection rate continuously. And as you can see, you can have this type of dashboard with all all the characteristics to be under control. Here is a typical example of a large POP player in Germany. They have about 5 systems, fully automatic, to control their production line. So this is ready to work, as explained. Just need to connect to the compressed air for the automatic valve. And we also need some water, fresh water, just to fill in the pre-con tank. And as you can see, it's a nice installation. Just to give you an idea, the rejection rate of this customer is below 1%. It's 0.5%, something like this. Just to give you some references, we have sold so far more than 200 units since 10 years now, and this is a non-exhaustive list of existing customers. We have sold it in India, of course, in Canada, in Mexico, in Europe, in the US, almost everywhere in the world. So just to make a little summarize, by using this device, you will be sure you will limit the rejection rate because you will have reproducible results. You will also have less risk of error due to incorrect inputs by the operators, and everything will be done automatically, rinsing, venting, pre-coating, and all the documentation and control are included into the screen, and it's really, you can also integrate it to your overall process, just to reach Industry 4.0. And we can also have the control, a remote control, to assist you for maintenance. This is also something really important. And it leads also to a lower chemical consumption. So thanks for your time, and if you have any question, please let me know. You can come to our booth, and I will be pleased to discuss more in detail about that. Thanks for your time.
Any questions? Any questions? A low-cost satin nickel for optical finish, described very well by Mr. Pascal of Shebeck. It is a very useful. Give a clapping to Mr. Pascal. Thanks.
Before we getting into or going to the future, what possibilities are there? Let us have a look what was there earlier and what is with us today. the initial stage of automation was started probably in the period of 1970s, with electrical control wirings and logics using relays, electrical timers, etc., which was subsequently improved by introducing microcontrollers for dedicated application. And then later stage the PLCs were introduced for programming and controlling the industrial machines and plants. Further improvement happened with PLC supporting by a SCADA system, which can have a good level of visualization and reporting features, controlling features, etc. But again, this PLC controlled system with PC as a supporting module has its own limitation. If we think about some complex algorithms like say multiplating lines, different process in the same line, or even a single line with multiple components having different thickness requirement and many more complex algorithms, getting together into one line, then this PLC control as master and PC supporting has the limitation in development, which has to an extent overcome in the industry by converting or by developing PC software as the master point and PLC following the PC for necessary controls and operation of the plant, taking care of the safeties and standards and other parameters. So this reversal from PLC as the master to PC as the master had given opening for introducing the IoT systems, artificial intelligence, machine learning for achieving better decision making and better flexibility and better control of the process. So basically in that IoT and artificial intelligence, when we are talking about these two features which can be injected into the automation of the plant. So what is meant by IoT? IoT is basically a technology which capture inputs from the plant, from the field, from various type of sensors, maybe a pressure sensor, maybe a temperature sensor, any type of sensors, capturing data, which of course a normal sensor, as on today plant also normal sensors are capturing data, but this IoT sensors basically capture the data and it has its own intelligence built in it. So the data will be captured, it will be filtered, it will be properly analyzed by the sensor level itself, and then subsequently it will be transferred to some server or any storing media, which can be either the cloud or whatever. So this is giving a lot of advantages, like for example a plating bath, maybe a bright chrome plating bath where the current break is a very critical thing. In case of even if there is a current break for a moment, it can create or it can result in rejection of the batch. So it is very much necessary to capture the data at a very short interval, current value at a very short interval, maybe once in every fraction of a second. It need to capture the data, and such level of data capturing will definitely make the server or the cloud, when the data is transferring in such a fast rate, such a huge quantity. So to avoid that, basically this intelligent sensors, IoT sensors, they just filter the values, like whenever there is a change in current value, or whenever there is a change, say maybe up beyond 10% variation, in such condition only the data will be sent to the server or cloud, and where a proper analysis will be done by the software, and proper analysis will be done by the software, and necessary corrective actions. Certain corrective action the system itself will recommend. Certain corrective actions may be required human assistance, so alert messages and alarms, etc. will be generated. For example, a chrome plating bath, where the current density required to be given, or total, or in other words total current required to be done, is very much depending upon the temperature of the solution. So reading both temperature as well as the current into the saving mechanism, with these two parameters comparing together, it is possible to adjust the CD automatically without any human interference, depending upon the so that means any process parameter which can be or which required to be controlled reference to some other parameters in the same bath. There are so this is the example for the sampling rate. Suppose the sampling rate is very high, then it is very difficult to understand certain deviations which is happening in the system. So the faster sampling rate, which will give better there are various types of sensors in the IoT supported sensors in the industry, which are basically maybe a pressure sensor, maybe a temperature sensor, maybe some acid content, fume content in the atmosphere. In a plating plant, always there will be some level of fumes. So the sensors of different requirement, different applications, which can be basically connected to IoT system, and data can be saved in the server, and then this data with proper algorithms defined in artificial intelligence and deep learning can be used for better and effective control of the plating plant, which is how it is going to use in artificial use in the plating process, the control of artificial AI and deep learning. That Mr. Aman Moore will brief it to you. Thank you.
So as everyone knows, AI is like the buzzword at the moment. And I just sort of break down what AI actually is in a sense and what parts of it I think we can play a bigger role in plating going forward. So AI itself is a lot of smaller parts: machine learning, natural language processing, which is usually what ChatGPT is, computer vision, where people are trying to identify what's there in photos. And we're looking more at machine learning, specifically at deep learning and supervised learning, which I'll just go over in a bit. Supervised learning is basically where you can give a computer a lot of data, like a lot of data points, a lot of lines of data, and first you tell it that, okay, so in the first line, where the area was such and such, the tank 1 has this pH, this temperature, tank 2 at this pH, this temperature, for this long. And after once you feed it about a few thousand lines of data, it can start trying to make connections. It can start trying to guess, okay, given this structure of data, this part might be fine. This part might need extra testing. This might be rejected. So this is where you can basically teach a computer to judge thousands or millions of parameters to come to one conclusion based on what you tell it first. Deep learning, on the other hand, is where you don't know what the pattern might be. So I know I've put in one part through a process, I put in the next one. How would that affect the temperature for the next part? How would that affect pH? Do I need to make any adjustments for it? That is stuff which is not necessarily linear, that we can't really easily do the math and figure out. But again, that's something where computers can help us. They can start just going over the data and figuring out, and just finding patterns humans probably can't. And so we want to use both of these along with all the IoT tools Mr. Mohandas mentioned earlier to see how that could help us optimize plating. The first one, of course, is prescriptive maintenance. We're very used to like reactive maintenance, which is when something breaks down, fix it then. The current trend is also predictive maintenance, which is when we see that, okay, this part might be, we can see imminent signs that it's going to fail soon. So let's correct it now. Well, with AI, with IoT and with pattern sensing, we can start going prescriptive, which is, while the part still works fine, when we see it's trending towards having issues, it can maybe suggest smaller fixes, which can delay the breakdown to a time which is more manageable. Maybe we can get to a point where a computer can just say, hey, this motor just needs some lubricating, but you might need to fix it in a while. But for now, just lubricate it, then maybe it'll last 3-4 days longer. Secondly, again, coming back to supervised learning, as I said, it can identify which points or what parameters are keys to the final plating performance. So if, for example, it finds out that the temperature in tank 1 was critical, going forward, if it, as we're monitoring everything in real time, if it sees that, oh, the temperature has gone off, it can alert the operator right then, and it can also maybe start working on suggesting corrective measures to make sure that that batch doesn't fail. Another thing which we're very keen on is closed loop plating times. Right now, plating times are, while mathematically calculated, they assume a perfect scenario. They assume perfect cleaning, perfect rinsing, and yes, there is some buffer built in. But what if we could get to a point where we can have maybe a small proxy, say a ball bearing on the flight bar with the part, which is going through the process where thickness is being monitored, maybe by thickness, maybe by some other measure we can come up with, where instead of just having to plate and then check, we can just check every fraction of time t. We can keep monitoring to see that is the plating thickness good enough. If it isn't, stay in there for a bit longer. This will help us reduce rejections or failures because every part will be plated as much as it needs to. And finally, bringing computer vision. Right now, we still need people to, even with low-to-zero software, like the one we recommend, people still need to feed in which part they're putting in, how many of each. We can look at tying that into the computer itself. Let the machine see which parts are being loaded in and feed that into the software itself. We don't need an extra person just for that. So the person just needs to load the parts in and the machine can then figure out the rest. What parts, what type, what material, what process does it need, and just optimize the process in that way. And with all this stuff coming together, at the end of the day, this is all to help us improve operating cost of plating. We can bring in IIoT and AI and ML to help us reduce breakdowns, reduce rejection, optimize our spare part inventory with prescriptive maintenance, and optimize man hours. We can make sure that we feel AI and ML and IIoT can help us bring down our operating cost of a plant. And that, at the end of the day, is what all of us are looking for. Thank you.
Thanks a lot. Use of AI and IIoT for plating automations by a progressive young man, Mr. Aman Moore and Mohan Das of Croydon. We have defined enhance the surface finishing process. This is a new topic they have added to the electroplatings other than the platings. Very nice. Give clapping to both of them.
I'd now like to call Mr. Praveen Kumar and Mr. Subroto Chakraborty on the stage for the next lecture.
Good afternoon. Namaste. My name is Praveen Kumar and I have been associated with this organization, Grower and Valley India Limited, for more than 20 years, and currently I am assisting Mr. Subroto Chakraborty, Head of R&D, for establishing the anodizing products and also imparting the technical services. Thank you for the opportunity to share our insights on complete solution on anodizing needs. We are excited to discuss the insights and findings from the paper which we will be covering today. So during the presentation, we will explore the overview points covered in the paper, like the basics, and the process sequence, the steps covered in the process sequence, oxide film formation, and the characteristics, properties of aluminium. So aluminium and its alloy offers a lot of variety of properties, such as lower weight, low density, high strength, higher electric and heating consumption, and then it is suitable for a lot of applications like the electric vehicle housing and also the solar housings and architectural structures. The only disadvantage is the bare aluminum is unused because of its low corrosion properties. Also its low strength, so it needs a treatment like the best which is being treated is like the anodizing. And there are three classes of anodizing. Like the first is the chromic acid, which creates the oxide film. It has a lower thickness, but it's very good in corrosion. So it is mainly used as a primer for paintings. And since the dimensional loss in this process is very less, so it is used in a lot of precise applications like the aerospace, military applications. Second class is the sulfuric acid based anodizing, which is the oxide film has a lot of porosity, so it is very feasible to have a lot of color applications. So it's mostly used in decorative. It has a very good abrasion and corrosion resistant properties. So it is used in a lot of architectural and decorative applications. And the class 3 is the hard anodizing, like the sulfuric acid, used with a very higher voltage and low temperature. The thickness is very high and it has a very superior abrasion and hardness property next to the diamond. So it is used in a lot of military applications. So a lot of properties for anodizing we will be discussing here. Aesthetic, like a lot of textures can be achieved, like matte to bright gloss, bright like a glass mirror-like finish. And since it is porous, a lot of dyes and colors can be achieved. And the coating is integral bond of the metal, so there is no deposition, so less chance of peel off like the paints. The color stability is very good, like the Alto colors, which has a very good exterior application used, and it's recyclable. Also it's a green finish coating, safe for health. The recent requirements in the field of anodizing is the aesthetic value, like there are a lot of textures, matte, gloss finish, which can be achieved by the mechanical and also by the chemical process. Deposit thickness is mostly in the finishing coating, like the 3 to 15 micron. Good corrosion resistance. They ask for neutral salt spray more than 360 hours. Water repellent test, water resistance test, which should be more than 240 hours. Alkali and the chemical resistance, alkali and the acid resistance, which should be more than 20. Sealing test, the mass loss. And adhesion test, also the UV resistance. If it is more than higher fastness test, it should be good for the exterior applications. The process sequence which follows as like we clean it, remove the soil, dirt, then we go for leaching to remove the oxide film, then the desmutting, whatever desmut is prepared, you have to remove from the desmutting. Then if it needs a surface conditioning like the brightening, so we go for a chemical polishing or auto polishing, followed by again desmutting, then anodize, and different, since after anodizing the oxide film is porous, so we can have a lot of options for coloring, which can be electro color or immersion wool, followed by sealing, which could be again with the two forms of like hydration, like the hot sealing, and the metallic salt impregnation, like the cold sealing, then in the final hot water dip. So we will, as I discussed earlier, we will go by stage. So in the etching, normally in the traditional way, people used to use the caustic soda, but there is a lot of disadvantage in that. A lot of sludge is formed, which is like hard like sludge in the bottom. So during the maintenance, a lot of difficulties been faced. So we have to introduce the additives. Nowadays we introduce additives, so which will give a uniform etching. Also, there is no sludge which is like hard like rock. You can see the diagrams. You see with caustic soda you find the hard solid lumps, and with the additive the sludge is with a slurry form, which is easily removable, so we can have a better maintenance and higher bath life of the etching bath. Acid etchants gives a very uniform and mild etching, and if you see that the RF value, you can make it out that the etching is uniform and less metal loss, 0.8 to 1 gram per square meter per minute. Minimal sludge, so its process is very good for handling, mostly used for the pre-treatment for before painting or chromating, and also for the anodizing where you don't want to lose your brightness. So this can be used because mild etching, so brightness is not lost. Higher bath life. Electropolishing, again the surface preparation. It is done by the electrochemical whitening of the surface. It gives a very good reflectivity and brightness. In the manufacturing process, like during the extrusion, there is a lot of burrs and all, so it could be also removed with a fine method. The temperature is 60 and the voltage is around 20. So So for the anodizing, when you need a bright surface, this process could be used. We have another method which is again a chemical polishing. Here there is no electrolysis, there is immersion. Basically it is used as a phosphoric and sulfuric acid mixture, and traditional method was to use nitric acid to get the brightness. But after introduction of additive, we can be free from nitric, like the dense yellow fumes can be excited, and with the additive you get a very bright finish. Also there is no patches. In the earlier process we used to get patches in the nitric, and you can see from the diagram there is a lot of yellow fumes, but with the additives we have a very good brightness, which we will see in the next slide. You can see on the gloss meter, we can clearly identify that with the additive, the glossness is very high. So after etching, we have to resmud it. So with the resmud, the traditional method was to use the nitric acid, but with the additives, now the resmudding is faster. Also there is no white powder finish. And in the anodizing line, there is a loss of wastage of sulfuric acid from the anodizing. So some people can also be use sulfuric acid as a desmutting with a additional additive which imparts the oxidizing properties. So basic method how the anodizing works. In the beginning is a sulfuric acid bath with a voltage. The anode is held as an anode and immersed in a suitable solution like chromic acid or sulfuric acid. Initially this is with the sulfuric acid. In the beginning the oxide film is non-porous. Then as soon as the coating goes up, it becomes porous. So it is easily good for the coloring stage. So once the oxide layer is generated, the pores are developed, we can have different types of color. So we are discussing here the organic and inorganic immersion dyes. You can see it's absorbed on the anodized film, and the consumption of organic is around 3 to 7, and for the non-organic is around 10 to 25 grams per meter square. The color is very uniform, and you can see the concentrations and the parameters mentioned here. It is very suitable for indoor exposures. Some of the dyes are available which has a very good light fastness and UV resistance, can be also used for the exterior applications. Now it's the electrocoloring, where the deposition is done to the metallic ions like the nickel, copper, and the intensity of color is dependent upon the deposit metal. Like the deposition starts from the bottom of the oxide film, and as it goes up, the color will be denser. So there are some additives which enable us to get different types of color from champagne to black. We can get different textures like matte, bright, so like 3-4 colors with both the finishes we can achieve. Filtration is necessary for the idle period, and the cathode to anode ratio is around 2:1. After any of the coloring, it is followed by the sealing to complete the pores. So there are two methods. One is the high temperature sealing. You can see iron trioxide is being reacted with water at high temperature to form a mineral biomite, which is mostly suitable for silver natural finish, or also for the immersion dyes. We suggest the hot sealing, and for the electrocoloring we can go for cold sealing, which is a metallic hydroxy fluoride precipitation. We can save some energy here, so it helps in the costing. There are some tests after sealing to confirm, to assure that the sealing is done at the proper level. So it's the anodized component. It is being spotted with nitric acid, white, then a dye of any ink.
and the ink should be wiped off easily. As you see with the additive, it's totally clear, and with the contemporary cold sealing process, the dye is being still there. That means the sealing is not done properly. So in this some additives, contemporary process, the jobs has to be kept for some buffer time like 24 hours. But with these additives, if you check immediately after the process, the ink is wiped off, so the sealing is very intact. There are some tests, alkali tests. It is being described like it passes around 600 hours for different types of products, additives. So thank you. I would like to invite Mr. Subir Chakravarti to carry forward.
Good afternoon, and thank you Praveen, to take us the basic anodizing processes. I will just take you through some of the recent development, particularly when we are talking about the anodizing of some of the alloys. And we all know that the alloys can give some of the basic, advantages, particularly to the designers when we are talking from shifting from the architecture to the automobiles. You can see there are advantages of different type of alloys are mentioned in this slide, but particularly I take you to the high silicon rich processes where the design freedom is much more, so we can get a very sharp attractive design for wheels or some other areas. So those things, so improve castability. This is very important for high silicon rich processes. But at the same time, when the silicon is more, it creates a lot of problem while doing the anodizing. So Praveen has explained the basics of anodizing a little bit ago, but think with a different perspective. Now what happens when the alloys contain some of the elements like silicon? What happens when you do the etching? The silicon comes on the top surface and it forms a segregation with other metals. So it blocks the further growth or any, when you do the anodizing, the silicon on the top surface, it holds. So further growth on the silicon is not possible because silicon cannot be made oxide layer. So, and furthermore, on the below the silicon molecule, there are some gaps created. So eventually what happens, we don't get good anodized layer. So you can see on the top, the phenomena takes place in the same way. Like first layer is the basic barrier layer, which he has explained. So B position, what happens when this segregation takes place, the anodizing layer growth reduces. So you can see on the graph, it comes down, and this after a certain period, what happens that further oxide layer growth takes place. So you can see that that thickness goes up because of the dissolution of that segregated layer. Now what we do for this type of processes, when we know that silicon cannot be oxidized and silicon is creating problem and silicon is in the basis material. So if you cannot do any oxidation or if you have some problem, so it is better to manage the situation. So we call it conditioning. So after cleaning we do the conditioning, but where the harsh alkali or harsh acid is not being used, it use some of the proprietary additives, and thereafter dismutting, of course the similar way, but preferably here we use sulfuric acid with additive system, which you have seen it. Most importantly, in the anodic process, we use some of the proprietary dicarboxylic or polycarboxylic acids. Those acids actually influence the pore structure, making it larger. So eventually we can get the better deposition. So this is the you can see on the SEM the ADC12, which is containing approximately 12% silicon. The first layer, where traditional process you cannot go more than, let's say, 3 micron. Now you can see on the bottom part of the cross-cut layer of an anodized ADC12 components, we have developed 20 micron deposits. So that's the one advantages using the proposition what we have just described. with this, I conclude our discussion, and maybe if you have any query further, and you can come to our stall, and we have some components as well. You can have a look on at that our place. Thank you very much. Praveen, please come.
Praveen sir. Thank you, Chakravarti ji. Praveen, please come.
A complete anodizing process given by Mr. Praveen Kumar and aggressive Mr. Chakravarti of GW. Have a clapping to them. Any more questions? There is no time, please.
Next, total we have 43 lectures. This one is lecture number 40 and will be presented by Mr. Himanshu Chauhan, Product and Marketing Manager, MKS Autotech. He is BE Chemical. He is having more than 20 years of experience in this field. Please welcome Mr. Himanshu Chauhan. Please welcome. जाने के लिए यहाँ से from this so it is now पीछे जाने के लिए
so good afternoon everyone. So today I will talk about the sustainable future with chrome free and trichrome plating. The future without Chrome 6, we will talk about Covertron 600, we will talk about trichrome process, and finally outlook and summary. Future without Chrome 6, we will talk about the Covertron process, the pre-treatment for plastics, and trichrome plating. It's a alternative hexavalent chrome plating. As all we know, the use of chromium trioxide will be banned for surface treatment in future. For plating on plastic, first we will talk about the chrome-free process. For plastic, you can see at the first step, we make the plastic conducting. In the second step, we do the multi-metal plating like copper, semi-bright, bright, MPS, then trichrome. So we will talk about the chrome-free process. If we talk about the etching pattern, it is similar to our hexavalent process, and it fulfills all the industry requirement with respect to the appearance, thermal cycle test, cooling performance, and it passes all the OEM requirements. If I talk about the peel strength, we can achieve the peel strength for ABS, this 15 to 20 liter per centimeter. If we talk about the PC ABS, the range is more than 4.5, but we are achieving 7 to 10 liter per centimeter. The peel strength basically need to check the adhesion performance. If I talk about the standard process sequence is similar to our existing process. Like the weighting is optional, then etching, then reducer, acyl pre-dip, then activator, accelerator, electrolysis nickel, and finally the plating grading, this acid copper and semi-bright, bright, MPS and trichrome. So in case of hexavalent, we can convert the existing line. It's a one-to-one replacement. You can see the sequence here. So only here the chrome 6 etching is replacing by chrome free. Rest the process sequences remain same. So for continuous production, yes, we need a CRE unit to keep the solution active for etching. If I talk about thermocycle results, yes, we tested many parts for many OEMs like Toyota, VW, GM, and this achieved all the thermocycle test. Even we qualify PV 1200 also. This is a very stringent test for thermocycle. If I talk about the compatibility with the resin, so right now it is compatible with the ABS and ABS PC. If I talk about the many resins like Novolog P2MC, Cyclolog MC1300, and this Carolon Cyclolog UMG and many more, it is compatible. And we also tested for the other materials like PEEK, PEI, and we can plate the PEEK, we can plate the PEEK and PEI material also. And with respect to selectivity, yes, it is suitable for 2K and 3K component. 2K and 3K component, it's mainly two kind of plastic, and 3K component is three types of plastic. Basically, in 2K component, in one type of plastic we need a plating. For other kind of plastic, we do not want the plating. If I talk about the field experience, yes, we have validated the process for ABS and ABS PC, and it fulfills all the OEM requirements with respect to thermal cycle, appearance, cooling performance, and more. And we did the validation for interior parts as well as exterior parts. For non-automotive, it is under production condition. It is production for ABS and PP for non-automotive. If I talk about the field experience, yes, it is ability to plate ABS and ABS PC. It is also suitable for PP and PEEK and PEI and 3D plating and many more. If I talk about the OEM requirements, it fulfills all the OEM requirements with respect to the appearance test, with respect to the cast test, and it is also compatible with the 2K and 3K parts with respect to the selectivity. Now I will talk about the trichrome plating. It is the alternative hexavalent chrome plating. Yes, in future the hexavalent chrome plating will be forbidden for surface treatment. For trichrome, we have trichrome bright finishes and we have dark finishes. If we talk about trichrome bright finishes, we have trichrome plus, we have trichrome ice. So our trichrome ice is very close to our existing hexavalent chrome finish. If I talk about the dark finishes, we have trichrome smoke, we have trichrome shadow, we have trichrome titan, we have trichrome graphite, we have trichrome phantom. And all our process will fulfill all the requirements of OEM. It's already approved by many OEMs. It is in the running production. So if I talk about trichrome smoke, and this is a warm light gray color, trichrome shadow is a light gray color, trichrome titan deep blue gray color, trichrome graphite dark warm gray color, trichrome phantom darker warm gray color. So with respect to the test, basically it fulfills all the OEM requirements with multi-layer nickel with respect to the casters, with respect to the appearance and other OEM requirements. So if I talk about the dark trichrome plating, in dark trichrome we have a trichrome smoke, we have shadow, graphite, titan, phantom. And it's very stable color and ideal process for all the automotive designer, and many finishes already approved by OEMs. It is in the running process. Yes, the post-treatment is required for trichrome finishes to enhance the NSS resistance. So we have two processes for post-treatment. One is Tricell 300, other is Tricell 500. So Tricell 300 is suitable for bright finishes like Trichrome Ice and Trichrome Plus. And whereas Tricell 500 is applicable for both, for bright finishes as well as the dark finishes. Dark finishes like Trichrome Smoke, Trichrome Shadow, Trichrome Phantom, Trichrome Titan. Yes, so business in Trichrome, we have more than 40 years experience and we are fulfilling all the OEM requirements. So it is the future, it is the alternative of hexagonal chrome plating. If I talk about the standard process sequence, the standard process sequence is similar. Only thing we are replacing the hexagonal chrome. So the standard process sequence, mainly the semi-bright nickel, then bright, then MPS, then we do the activation, then trichrome plating, and finally post-treatment to enhance the NSS resistance. Outlook and summary. So we have a solution for process as well as equipment. So above the chrome-free process meet all the requirements with respect to the customers as well as OEMs. We developed our process. It is suitable for ABS and ABS PC both. So we are in production for automotives and we are PFAS free. As a deadline to use Chrome 6 for decorative application may soon. So also the OEM are selecting new references to migrate Chrome 6 free process. Thank you. Sorry, beyond the reach. So we have a chrome free process covered on, and also we have a trichrome plating is the alternative hexagonal chrome plating. So all from one source.
Thank you very much.
Thank you.
Thank you very much, Himanshu Chauhan.
Thank you.
And we have to replace hexavalent chrome by trivalent chrome 100%, not now, but in near future. And for that, because we cannot compare hexavalent and trivalent together. Trivalent is a acidic bath, but it requires some additives. So hexavalent has already not necessary to have any fine, it is self fine grainment. And here it is not fine grainment. So how to make it more fine grainment? Hard chrome in trivalent, that we have to think for futures. Very much, very nice. This is a beginning of the new field. In trivalent chrome, we have to replace hexavalent 100% because it is hazardous to the human beings. Thank you very much.
Any question? If you want to visit our stall, we can show the different trichrome finishes.
May I now invite Mr. Praveen Kulkarni of Ground Well He's going to talk towards zero liquid discharge. Mr. Praveen, please introduce yourself. Apologies, Mr. Parag.
Yeah, it's okay. It's okay. Good afternoon, everybody. Myself, Parag Kulkarni. I have been working from past 27 years in the field of water and wastewater treatment systems, recycling projects for various industries and various applications. Earlier, I worked with companies like Eureka Foam Limited, Praj High Purity for water and wastewater both. Also for Ion Exchange India Limited, working on to the various filtration techniques, various reverse osmosis and pre-treatment systems for membrane systems. Also, hands-on experience with a lot of MEs and MVRs for recycling and condensation of the high solid waste. Today again we will discuss about the advantages, disadvantages and of ABs and MVRs and various techniques to save on the water quantity going to the ZLDs and going to the effluent treatment plants. Innovations in effluent treatment and recycling, this is our today's subject for discussion, which is most vital importance, because as we do the plating and metal finishing, we are generating a lot of types of effluents, and that also needs to be treated. Our today's content for the discussions will be effective effluent recycling. Now there are various ways for doing this. Is optimized design of plating plant. There are certain things which you need to take care while designing of the plating plant itself, so that the water reuse and water saving can be planned properly. Then reduction of effluent generation, recovery of effluent between the interstages, then decentralized treatment, and how to reduce the capex and opex costs for the treatment of effluents. As we know, we are from this industry, we are generating effluent from the degreasing solution baths, which are drained out after every 45 to 60 days. We also have bath and process solutions which are also needs to be cleaned and recycled back. There are a lot of contaminants which goes into during the rinsing processes, and that also needs to be covered. Rinsing of component, while it happens, there is a lot of carryovers of metals like nickel, chrome, zinc, iron, that also etc. needs to be removed, and water needs to be recycled back into the process. Similarly, pickling and passivation of the effluents also generates a lot of effluents, and that also needs to be treated before sending it out to main effluent treatment plant. Now, reduce and carryover of chemicals. Like we do the chemicals bath, we have the zinc bath, nickel or chromium baths we have. Before going directly into the rinsing stages, ideally we should introduce the stages like drag outs, which will concentrate the drag out baths, and the drag out baths can be recycled back into the main chemical bath to replenish the losses because of the evaporation losses and the drag out losses. Reuse of chemicals. This means that whatever baths you are using, like example is you are using trivalent bath for passivation after zinc processing. Now zinc and iron will get carried over into the passivation bath, chrome trivalent bath, and the chrome trivalent life of the chrome trivalent bath needs to be improved by removing the zinc and iron from this bath. Now this is to be done as a side stream filtration and on continuous basis, so that the draining of the passivation chemicals is not required very frequently. The life of the chemical can be increased, and draining of this effluent going to the main effluent treatment plant will also going to increase the load onto the effluent treatment plant, and also the cost of treatment of the effluents. Rinse water, as we know, rinse water typically contains the TDS of over 3,000 to 10,000 ppm, and that water, rather than going directly into the waste streams, this water can be recycled back, further can be concentrated to 40 to 50 or 60,000 TDS,
And this recycled water from the rinse bath can be fed back into the rinsing tanks, also can be reused for feeding to the DM water. Like DM water will be using for the degreasing baths and also for preparation of the chemical baths, which is the main ingredient in these two tanks. To the extent possible, we should go for the decentralized treatment, like we are doing the recycling of the rinsing. There should be also treatment methods like basket filters or screen filters for continuous filtration of the rinsing baths or the passivation baths, which will help carry over of any dirt into the rinsing tanks and then back to the process, so that the rinsing volume can be maintained. Now next comes to the automation. When we comes to the automation of the treatment plant, automation helps us a lot. This basically reduces the manual intervention, avoids the mistakes, and also does the chemical dosings very accurately without having any wastage into the systems. Wastage of chemicals will lead to again increase into the CODs and increase into the OPEX and capital cost for the main effluent treatment plant. Automation can also be done for the rinsing tanks, like we can introduce the level instruments. Along with that, we can introduce the conductivity sensors to maintain the optimum conductivity of the rinsing tanks water. So this will ensure that the rinsing tanks are not continuously overflowing. So this is a typical plating process flow, wherein we will be having the process tanks and then we will be having the rinsing tanks. And the effluent generated from this process is going to the ETP and the ZLD process. Now typically into single rinse tanks processes, the rinse water is continuously fed and continuously drained. Overflow water is continuously drained to the effluent treatment systems, which leads to generation of effluent at a very higher quantity. This needs to be reduced. And now either you can go for the next type like cascade rinse, or you can go for the triple rinse, which we will discuss further. In cascade rinse, typically you will have two tanks, one after another for the rinsing baths, and this will reduce the volume by almost 50% as compared to the single rinse, because here the water is reused and the carryover is managed in two tanks. Triple rinse is the most effective way of doing the rinsing, because this will reduce the rinsing water consumption by almost 72%. Like in single rinse, it consumes water about 300 kL per day. For cascade rinse, it will consume 159 to 160 kL per day, whereas in triple rinse, it will consume about 85 kL per day of the water. So the load, like if we compare, the single rinse will lead to 300 kL of effluent generation treatment into the effluent, increasing the volume going into the effluent treatment plants and zero liquid discharge systems. Cascade rinse again 50% reduction, and going for the triple rinse will give you the 72% reduction for the generation of the effluents. Lesser the effluent generated, lesser is the cost of OPEX, lesser is the cost of CAPEX for the effluent treatment plants. And that should be the main focus for while designing the plants. So when we go for any designing, any implementation of the plating systems, plating plant, these things should be taken care while designing itself. Now this effluent generation can further be reduced by using inline DI systems. Like as explained for the passivation bath, chrome passivation bath, we can use the DI systems, we can reduce it. Similarly, into when we are recirculating the rinsing water. Rinsing water typically will contain the traces, even if we do the basic precipitation, like if we have the chrome hexavalent, we are doing to the chrome trivalent, the acidification and SNDs, then even that some carryover will happen, some traces of heavy metals will still be present. Rather than moving that water to the UF and RO for further recycling and reducing the TDS, and then that will lead problems into lesser life of the membrane systems. Typically the membrane system should last for about 3 years, whereas in the presence of heavy metals, Even though there are traces, it may be 0.5, 0.6 or maybe even some cases 2.5 or 5 ppm as well. That will lead to reduction of the membrane life. So that will again going to increase the operational cost of the effluent treatment systems. So there are special medias and deionization systems available wherein it can target the specific heavy metals like nickel, chrome, silica, reactive silica kind of metals from the bath, and then the water can be recirculated very easily. Now, as we know, there are two types of evaporation available. Now, the basic treatment is when water, to the extent possible, we have recirculated within the systems. Rest of the water with higher TDS, 40 to 60,000 TDS, will need to be burnt off, and then the water again needs to be produced. Water needs to be separated as water vapors plus powders. For doing that, we have two techniques available in industry today: is multi-effect evaporation systems, and second is mechanical vapor recompression. Now, both systems are having its own advantages and disadvantages, but installing for a ZLD systems, MVR proves to be the better option considering the operating cost. Operating cost is a regular cost which you need to incur for treatment and recycling of the effluents. Typically, when we talk about the operating cost, this is 40 to 50% lower as compared to multi-effect evaporation systems, and also it operates in the lower temperature segment. This comes to 55 to 60 degrees centigrade is the operating temperature or of the MVRs, whereas into the MEs the cost is 2.5 rupees to 3 rupees a liter or more than that also. Again, when we go for MEs, typical industries are going for the two-stage MEs. Now, two-stage MEs will definitely have higher cost like this, and three-stage MEs will have lower operating cost, and that is the economy it can offer. And against three-stage MEs, MVR is the better option going for the industries. So, for survival of our metal finishing industry, let's follow the survival mantra of reduce, recover and recycle. Reduce the wastage of water to the extent possible, recover as much as possible, and recycle as much as possible. Thank you.
Thank you very much, Parag Kulkarni. Are you aware that today there is no water in Cape Town in Africa? So water is very necessary. The Cape Town became waterless nowadays. So to conserve water resources is very much important, and we have to accommodate this line of acting in surface finishing also. Thank you very much, Praveen Kumar. Sorry, Parag Kulkarni. I welcome Mr. Gal. Martin Gal, Managing Director, Far East Business of Columbia Chemicals. He has with Columbia Chemicals since last 31 years. And he is looking after business mainly in India and nearby India in Far East. His continuous support to Columbia Chemicals, partners to these regionals in all aspects of production supports, including sales and marketing. Technical also.
Thank you.
Okay.
Okay, hello. Now, can I use that?
No, okay.
Okay, thank you. Thank you. Let me use this one. Okay, it's nice. You want How about that? Yeah, that's a little better. Okay, welcome, thanks for coming. I know this is the end of the show. I think there's one more speaker. So I want to say a couple things. I like to advocate for the change of the ISF to be ISFF. Now, some of those who saw my talk yesterday might remember this, but the India Surface Finishing Family. Now, I know they're probably not going to do that, but it's truly a family. I came to my first ISF show in 2002, so it's been many years, and when I walk around and I see familiar faces, you know, it's friends, it's family. Not just, you know, customers, competitors, it doesn't matter. It's a fellowship, and that's what's important with metal finishing. So I was trying to think, since I know this is at the end of the show, we probably don't have many people who are going to come, so I want to do something a little different. I'll talk a little bit about the chemistry and the future, but I wanted to just share my thoughts about that. Alkaline non-cyanide zinc has been around a long time. We're going to get to that. Okay, why this picture? I'd like to have some kind of fun picture. If you don't know this man, it's Jimi Hendrix. He's a famous guitar player from the 70s. This picture was taken at Woodstock, which was a big music festival in 1969 in New York that was attended by 500,000 people. Jimi Hendrix closed the show. He was the last artist. But sadly, the show ran late, and what happened was he didn't go on until Monday morning. He was supposed to go on Sunday night. So by the time he went on, this big crowd pretty much was gone. There was only about 20, 30,000 people left from an original 500,000 people. So I was trying to draw a little bit of a correlation with that, because at the end of the show, I see a lot of empty seats, but it's okay, because those people who stayed got to see a great show and got to see Jimi Hendrix. Now, I'm no Jimi Hendrix, but I hope you enjoy the presentation. Just a quick little advertising. You know, my company is well established. We have partners all over the world. We like to partner with the local people. They understand the market. They know the market. Again, yesterday, if you were here, I mentioned in the beginning of my presentation that if you go out into this hall, in this room, there's thousands of metal finishing hours of experience, thousands of hours of experience. Now, someone came up to me yesterday and said, "No, Martin, you're wrong. You're wrong. There's not thousands, there's tens of thousands." And it's so true. So my point with this, non-proprietary, is if you can't find the information you need here, you're not going to find it anywhere. So I know we don't have much time today, but still, visit the booths and the stalls that you can, try to make the contacts that you can, and of course, all our suppliers that are represented will come and see you and provide the information you need. But my point, and this is kind of ties in with my talk, is for the future. Next show, 2028, mark your calendars. Let's start planning to come. I'm just going through some of these kind of fast because not that relevant for the moment. But my point, a highlight, is all of our supply companies that are representative here, we have great laboratories, we have great people. And my hope is that we continue to get more younger people involved in the industry, more education, and with that education will be continued growth. Okay, so we're going to talk briefly about alkaline non-cyanide zinc. Now, we only have about 10 minutes, so we can't talk a whole lot about it. But what I can do is I can get those of you here that are interested or possibly interested in alkaline non-cyanide zinc a little bit of taste of what we're talking about. And then, as I mentioned, go out there in the hall and talk to people, talk to the different suppliers. You know, alkaline non-cyanide zinc has been around a long time, okay? Now, I had to reference our product I'm trying to keep it proprietary, but I had to reference our products so that I can have some continuity with it. But the point is, the new versions of alkaline non-cyanide zinc are very tolerant to contaminants. Not always the case if you go back. One of the reasons in the early years that people didn't like alkaline cyanide zinc was they had a lot of contamination issues. We don't really see that anymore. That's been corrected through technology, through better chemistry. They can operate over a wide operating range of zinc metal and temperature. And most important, for those of you interested in alkaline non-cyanide zinc, the deposits are very ductile. If I had 100 rupees for every time someone used to say alkaline non-cyanide zinc blisters, I'd have a lot of rupees. Doesn't happen anymore, okay? Better additives, better improvements, we don't see that. So when someone talks about blistering, I'm like, nah, you haven't really kept up with the new technology. Okay? Again, very ductile deposit. They're bright, very bright, and excellent plate distribution. Now, these are arguable things, but I will say that alkaline non-cyanide zinc is the best zinc plating process out there. It's great distribution, it's bright, it's somewhat easy to work with. So again, if you're thinking about going which route, you have acid chloride, don't want to do cyanide, alkaline-free cyanide is the route to go. Now, one of the things that has changed over the years is the expectations, and this happens a lot in all facets of life. People have expectations of what they want. In the early days of alkaline non-cyanide zinc, it was new. People weren't sure what to expect, so they were very careful with the systems. They followed the tech data, they followed the chemistry, the filtering and all that. Now, since alkaline cyanide zinc has been around a while, people have gotten a little lazy. They get a little sloppy. And then what happens is that leads to problems. So it's important that you maintain your proper levels of operation and you use good chemistry. So the theme of my talk was that all alkaline non-cyanides are not equal. And why I said that is because some processes are much more tolerant to impurities than others. Okay? So, we won't even talk about that. And let's just move through. Okay, the main thing about the operating range, some of the older systems were more limited with the amount of zinc metal they could handle, the temperatures. Again, great improvements have been made. Now, I'm looking for the one slide. Okay, here we go. So, I tried to X out the names, tried to be less proprietary. But anyhow, I can speak with my product with intelligence. These polymers, these alkaline non-cyanide zincs contain polymers. Now, 20, 30 years ago, these polymers were a little difficult to obtain. Due to research and advancements, they are available, okay? Does that mean if I have this polymer, can I make a great zinc brightener? Alkaline non-cyanide zinc brightener? Not true. The polymers are only one raw material of the alkaline zinc brightener process. Again, companies with R&D and technology, we've now tweaked these polymers to make them a little bit more unique to our industry application, because these polymers are used in other industries. It wasn't exclusive to metal finishing. So we've now improved those polymers to do what we want them to do, which is important for metal finishing. So again, that's why the theme, not all alkaline non-cyanide brighteners are created equal. Most companies that you'll find in here, mine and competitors, will have two basic brightener packages, a main brightener and either an aldehyde secondary brightener. People refer to them differently, but they're pretty much meaning the same thing. It's a two brightener package. Now, actually, go back to that a minute. Another thing that's important that I wanted to mention in this is in addition to this polymer, there's intermediates. Now, intermediates are always proprietary. And this is, again, what makes some of these alkyl non-cyanide systems better or better performance than others. So, again, I can only speak for my company, but we manufacture this intermediate. It's a proprietary intermediate that we personally manufacture. Some companies purchase it. There's versions of it available. We manufacture it. And that additive, that intermediate, combined with this polymer, which is very well known, those are the wham-bam combination of the alkaline zinc brightener. And again, I say this because if you just have one, yeah, you can make an okay zinc brightener. I see it all the time. But if you have both, you can make a superior zinc brightener. So talk to companies like mine, others here in the booth, ask them about their systems. There have been advancements. And most systems will contain a purifying agent, a conditioner, and a fume suppressant. Now, a little history, quickly. In the early days of alkyl non-cyanide, the main chemical, I guess, that you'd use would be potassium hydroxide. Now, you might ask, why did they use potassium hydroxide? Because potassium hydroxide is historically more expensive than sodium. Potassium has natural brightener abilities, okay? In itself, potassium provides a little additional brightener. This is found in acid chloride as well. So you could have an inferior additive, use the potassium hydroxide, and boom, you get a little better brightness. But companies like mine, we did R&D, we did development with better intermediates, as aforementioned, and we've improved that so that you can get your brightness from the product itself, which then allows you to use sodium hydroxide. And sodium hydroxide is typically less expensive. There are some smells associated with it, which is why there's fume suppressors. If you have good ventilation in a plating shop, it shouldn't be an issue. But now, with, again, these improved systems, you can get very good brightness. So I just want to follow up to add, since this is kind of the last, one of the last speeches or presentations of the day, is we're not finished. We're still working on the next generation, the next improvement, the improvement to the intermediates. So in the future, and we hope in 2028 for the next ISF, we'll be able to introduce those here. So kind of a full circle. The show is ending. It's the last day, the last part of the show. But I want to end it on a positive note that we are looking for the future. And there will be future improvements and advances. And of course, companies like mine and others here will be bringing those to you. So that's it. Thank you for coming. Appreciate it.
Thank you, sir, for your refreshing presentation.
6. Your birth date number is 6 total.
Okay.
Thank you, sir. Thank you.
Thank you very much, Mr. Martin Gale, for giving very nice and aggressive speech.
I'd now like to invite Mr. Kushal Kindra. He's a techno-commercial person working in the metal finishing trade overseas for the last 40 years. He is BSc in chemistry graduate and MBA from IMT Ghaziabad. He has represented several companies and worked towards technical services in making various product groups in GMF, decorative nickel, CRC, hard chrome, EN decorative, silver, and other applications. Please come on the dais.
Good afternoon, everyone. Well, he has already introduced me, so nothing to say about. About this presentation and the topic, I have chosen this particularly because this is an emerging field and a lot of new technologies and new customers in the electronics industry will be coming up in this. यहाँ तो नहीं है, वो ले तो नहीं चुके. So the topic of the day, the topic of the day, emerging technologies in hard silver and tin plating for electronics and automobile applications. Thank you. It goes in the way that introduction to this, new opportunities and the applications that we can have in India in near term. The cable and connector market in India is expected to grow exponentially in next 5 years. From the current market scenario of around $5.5 billion, it is expected to grow up to $10 billion in next 5 years. And the current electroplating industry, which is estimated to grow to 12,000 crores on the back of high EV demand. In fact, the new surveys say that it will be something 15,000 crores by next 3 to 4 years. So that is why this topic is here, because most of our industries and plating houses will have to work hard, otherwise a lot of this chemistry will have to be imported. Most of the processes that will be coming will be gold, silver, tin, palladium nickel, ruthenium and white bronze. Another classification that another product which will be acceptable or will be used will be nickel phosphorus. Sorry, I am really sorry. And the base metals that needs to be plated are copper alloys and MS. Why we are applying these coatings on these components is to improve the corrosion resistance, wear resistance, of course the tarnish resistance and the heat resistance, conductivity and solderability. Solderability is a key factor for electronics industries, and that is why we are using all these products. Application wise, it's interesting that most of the instruments that you're using, like mobile in your hands and all other instruments, and the new incoming EV batteries, electric vehicles will have lot of components which will be plated with silver and tin plating, like lead frames, IC, connectors, electrical contacts, waveguides, then plated wires and strip plating, EV batteries, EV charging stations and connectors
for the powertrain. It will have an applications across all the sectors. The major being automotive, transportation, consumer electronics, defense equipment, aerospace applications, computer peripherals, health and medical equipment, telecom and data cables. All these are areas where these electronics applications are going to be used. Coming on to only silver plating, yes, we have different kinds of silver plating existing, and this has been existing for so many years. The only new things I'll be talking about is hard silver, which is cyanide based and non-cyanide based silver plating. For decorative applications, it has been in use since ages. For electronic applications, we have bright silver plating, but most of the people prefer matte silver plating without brightness. Why hard silver plating? This is a recent origin and requirement. I would like to tell you all. Why hard silver plating? Because of all the silver that we get plated right now is in the range of mostly 80 to 120. But with the coming of EV stations or EV chargers, connectors, because it will have an immense use of plug-in, plug-out, we wanted a hard silver. The customers wanted a hard silver so that the connectivity will not, and the charging is possible, and there will no thermal destabilization. In hard silver, we have a minimum 8 micron, and though I have written 30 microns, people may go up to 50 microns. So that is why the moment the thickness of the product will go, the hardness will, volume of business will grow for every one of us. More consumption, so more business. EV connectors can carry a current of 100 to 250 amperes. Nickel underlayer is necessary to prevent the copper diffusion, which is very common in this case. And hard silver, why prefer hard silver? Because it replaces the requirement of gold plating. Otherwise, people would have to go for gold plating. The functional requirements that we look at hard silver plating, excellent electrical properties, but since we have to make it hard, we are alloying it, so it is slightly compromised as far as the electrical properties are concerned. Other things like bondability, solderability and ductility remains good. Thermal stability, so far it has been tested that it is okay, but there are still many houses have to complete their inputs on this, and acceptable corrosion resistance after application of anti-tarnish, like most of the silver products are using the anti-tarnish products. So this is a product which finally will be used ever, because we cannot plate silver without any anti-tarnish. We have a low to medium hardness in the existing systems. So the functional requirement is that we need a hard silver 120 to 140 is the current status, but recently we have tested some of the products which can give a hardness up to 240 HV. Now hard silver processes are generally low speed processes because we cannot work them on a high speed basis, and designed for application involving the plating of connector parts using rack and barrel equipments. Now hard silver products are cyanide based, either potassium or sodium, and sodium based products have been found to give you more hardness than the potassium based products. It can produce electroplated silver with hardness values up to 120 to 240, and this is tested even after
even up to 100 degrees centigrade, if this is tested after 1 hour or 2 hours, the hardness drop is not too high. Normally it still stays above in the range of 180 to 200. How the hardness increased in this case? The hardness is increased by adding the hardening agents, which tends to co-deposit. The earlier hardening agent was antimony, but now different products are used like germanium and maybe I think silicon also somewhat. Oh, selenium, sorry. So this is just a exhibit of one of the plated components with hard silver, not very bright. The other product that I'm going to talk of is the non-cyanide silver, which I think, though many of the plating houses are trying this, even we were trying to sell a product for non-cyanide silver. First I talk of the products that are available, and then I will also define certain improvements that it will require in future. It's a neutral and slightly alkaline cyanide-free plating process which can plate semi-bright to bright electronic and can be used for electronic and industrial uses. Can also be used in reel-to-reel platings, but with a limited application of the current density we can't raise much in this case. The basic thing that it eliminates the high cost of waste treatment of cyanide and it operates at room temperature. The main advantage of this process is this doesn't require a strike undercoat. It can be plated directly onto all metals, while in the cyanide silver process we always require an undercoat. So this is the advantage of this. However, some people still prefer to use the undercoat. However, if we have to plate nickel as a substrate, then we do require a silver strike. If we have to only plate nickel as a substance, then we do require a strike. Alkaline silver as it is naturally hard process. It doesn't require any addition agents to be added to make it hard. That is the advantage of it. Its natural hardness is quite good as compared to the normal processes. Something close to 120 to 130, which we never get in the normal silver plating process. Deposit has a low porosity and a good bonding properties, and also has a good electrical properties, as good as a 99.9% pure deposit you can get with this. The other process that I am going to talk of is tin plating, MSA based tin plating process, which is a matte tin process and the bright tin process. Now, how a connector plating is done, this is a basic process sequence for normal connector plating that we use, which can also be tailor-made as per the customer base and the components that have to be plated. Components can change, the component alloy can change, so process may have to be changed. MSA tin processes are acidic and pure tin electrolytes used for various applications. Continuous plating of bus bars, wires, connectors and lead frames. This is the main requirement in modern reel-to-reel and spot installations. The process can be used for high-speed wire plating, which may vary from 50 to 500 meters per minute. So that's the beauty of this product, that while a continuous reel is being plated, and you can plate up to 500 meters per minute. The application can also be used in the normal rack and barrel process, which is advantage.
It provides a unique deposit that exhibits, due to their special grain structure, a lower whisker formation. Whisker formation is one of the biggest problem for tin plating. So we need to have a deposit which will be whisker free and will not, after the formation of whiskers, the connectivity loss is there, or you may lose the current passing. Matte tin deposit exhibits a good solderability properties. Deposit has an excellent reflow behavior and can be used with wide range of current densities from 5 to 50 amperes per decimeter square. Matte tin deposits on copper wire can be drawn. That once the deposit is made on thick copper wire, it can be drawn to 10 times or maybe more, depending upon your requirement. If you are plating 10 microns, you can bring it down to 1 micron by drawing. So that is the advantage of this process. Similarly, bright tin, we have similar properties, but MSA bright tin process are low foaming. Actually, what happens in bright tin, lot of foaming happens, so the plating gets poor. So we need processes which are low foaming. I'm sorry, I have got still 3 slides or 4 slides. And I hope since this is the end of the session, nobody minds me completing this.
End of the day and end of the year.
Sorry. MSF, so this has been specially developed for straps, wires, connectors and lead frames in modern reel-to-reel play and sports installations. MSA tin process produces fine-grained bright layers which exhibit excellent solderability. Normally in the bright tin that we have existing processes like with sulfuric acid, we don't find the solderability very good because of the high dosing of the organics. So these are the new range of brighteners which have where very less quantity is there and very less deposit is there, co-deposit. Pure tin, so my MSA bright tin is again a pure tin alternative because lead was creating problem. People wanted to move away from lead. It produces deposits with low tendency to whisker formation, I have already explained, and can be used to bright plating of strips and copper wires, but this cannot be drawn. That is a major difference between bright plating and the, I hope if, sorry, excuse me. Hi. This you can see the working of a wire plating, how the reel is going. Can you just replay once? So this is just a practical picture of a reel-to-reel plating that I have taken personally. Since I am speaking in an independent capacity, I am not taking names of any companies or even giving the statistics from any company to what range it can be used and how it can be used. So I am just making a general presentation. Now this is a general composition and is common for both high-speed tin, matte tin as well as the bright tin, where the major advantage that we derive of the MSA process is that we can use strainers up to 50 to 80 gram per liter, and MSA acid 150 to 220 gram per liter, and also basically there are proprietary additives which contribute a lot to the success of this process, and this is as per the supplier's recommendation. The main advantage of this product is that it can be used from 5 to 50 amperes per decimeter square and also used in reel-to-reel platings. We can achieve a deposit of around 10 microns per minute, 10 microns per minute at 20 amperes. This is the standard process for the reel-to-reel plating, but it can always be tailor-made as per the customer requirements. If there is a slight change in the wire compositions or the strip, like this process is used for strip plating as well, and terminal, all the terminals that we get in the automotive sectors in reel-to-reel plating are done in the reel-to-reel plating fashions. In case of brass strips, an undercoat is always recommended, otherwise it cannot be done. Coming to almost the last slide of it, slightly I have overshoot my time. Every silver and tin composition product after the plating will require an anti-tarnish applications, because both the products are prone to atmospheric corrosion and hydrogen sulfide corrosion from the atmosphere. See, the available products do meet a lot of requirements in the current scenario, but there is always a scope and need for improvement in this case, because with the new guidelines and the new requirements coming from the customers, different specifications, we need to improve these processes. In case of tin, the products mostly required are to prevent the discoloration in humid conditions and reduces corrosion of the tin finishes to mitigate the viscous formation. It should not impair the solderability, so that solderability is there retained intact. That is the main, it should not be impaired in any case. Most of the anti-tarnish are hydrophobic in nature. So that is one of the major requirements also for all the anti-tarnishes. Should also pass the steam aging test and the ROHS requirements. Most of the products that exist now in India also and marketed by different companies are all meeting the ROHS requirements. In case of silver, yes, we have both the types available, immersion type or electrolytic type. We also have recently, some of the houses have introduced trivalent passivations for silver. Electrolytic passivations, which are as good as the hexavalent passivations, electrolytic hexavalent passivations. The immersion type products are hydrophobic in nature, do not impact contact resistance or solubility. I've already spoken about the electrolytic passivations are also available. The major requirement should pass the potassium sulfide or the ammonium sulfide test. In India, we don't have the thioestimate test. People still are not undertaking it. And the products, of course, are required to be ROHS compliant. Sorry for being delaying you all. And this is just an image of silver without anti-tarnish and silver with anti-tarnish. Thanks a lot for all your attention, and thanks a lot paying a little more. Since this was a basic, I didn't want it to make it too technical. So just a general information what the future of these products and the target market will be in the required in the India. We may be working on so many things.
Thank you, Kiriraji, for your introductory presentations.
From my one claim from myself, tin bath is sulfuric acid bath, and this is MSA used bath. MSA used bath is more in a reducing state, so stannous to stannic formation will be less in this case. That they have not made.
Sorry, I really, that's what I said. I didn't make it too technical, but yes, I forgot to mention that. I'm sorry.
I request to Dr. Patolia ji, please felicitate. In future, this will take place.
Yeah.
Sir, I request you Dr. Patolia ji to felicitate Mr. Kindra ji. Thanks to Dr. Patolia ji to chair this session for wonderful. Thank you very much, sir. Sir,
We should thank Dr. I would like to thank Dr. Patolia for his valuable inputs and also that he has been with us for last 3 days, giving us due support and I would say he's a man of small words. Yeah. So this is the end of the presentations and we thank all our who have attended this and all our other presentations. We all feel it has been more or less a very successful sessions, all the three, and quite useful. Maybe industry needs to work on certain things which have already been depicted in all these things, all 3 days. Thank you everyone. Let's meet in 2028 again, if all goes well. Yeah, thank you.
afternoon, ladies and gentlemen. Attention please. We are going to start our ending ceremony of Indian Surface Finishing ISF 2024 by Mr. Vipin Garg, Maruti Suzuki India Private Limited. Our chief guest had arrived. He already requested to move ahead towards the conference area. Thank you.
Good afternoon, ladies and gentlemen. Good afternoon, everyone. I request everyone to please settle down as soon as possible as we are going to start the program in few minutes. Once again, I request everyone to please settle down as soon as possible as we're going to start with the program in few minutes. Thank you so much. Good afternoon, ladies and gentlemen. Welcome to ISF 2024. Well, my name is Azra Khan and I'm delighted to be your host today. So ladies and gentlemen, as we all know why we have gathered here today, it has been a fun-filling and business-oriented 3-day event. I request everyone to put some energy into this room by putting your hands together. Come on, ladies and gentlemen, can we all do that? Put your hands together and start this event with some energy. So, well, ladies and gentlemen, on behalf of MFAI, Metal Finishers Association of India, I would like to extend a warm and a very hearty welcome to each one of you present out here. I would like to welcome you all to the grand closing ceremony of the ISF 2024 conference and exhibitions. Can we all give a huge round of applause once again, ladies and gentlemen? Come on. And please help me invite on stage Mr. Sunil Goyal, the president of MFAI, with a huge round of applause. Come on. I would also like to invite Mr. Amit Agarwal, secretary of MFAI, with a huge round of applause. Come on, ladies and gentlemen. Now I would like to invite our guest of honor, Mr. Vipin Garg, Executive Officer, Maruti Suzuki Limited. Come on everyone, एक बार जोरदार तालियां हो जाएं Mr. Vipin Garg के लिए. So Mr. Vipin Garg is working as an Executive Officer in Quality Assurance Vertical. Currently, he is responsible for managing overall quality assurance functions in Maruti. He already has over 3 decades of vast experience in Maruti Suzuki in various functions of quality assurance like market and plant quality, supplier quality, and new parts development. He has also played a major role in establishing robust quality systems at MSIL and at vendor partners. Mr. Vipin Garg holds a BE Honours degree in Mechanical Engineering from IIT Roorkee and is associated with Maruti Suzuki India Limited since 1993. So can we all give a massive round of applause for Mr. Vipin Garg once again, ladies and gentlemen? So now I would like to invite on dais all the council members. So please put your hands together for Umesh Kumar More, Mr. Sushil Goenka, Mr. Bachu Ali, Mr. S. Sedu Raman, Mr. Rajiv Joshi, Mr. R.P. Khatana, MFAI North India Chapter. Come on, ladies and gentlemen, give a huge round of applause to all the council members. Come on. And also, I would like to invite Mr. Ashu Bajaj. Can we have a huge round of applause? Come on, everyone. Now I request Mr. Vipin Garg to say a few words and put some light on industry insights and recognizing excellence and innovation. So please put your hands together for Mr. Vipin Garg once again. Come on, ladies and gentlemen. I would like to also invite Mr. YP Bhalla on stage. Can we have a huge round of applause for Mr. YP Bhalla?
Can I also invite Mr. Mehra from Grorinville and Mr. Jagmohan Singh ji? Anuj is coming? ठीक है, अनुज जी आ रहे हैं? ठीक है, let him come.
So I would like all the council members to please felicitate Mr. Vipin Garg with a bouquet. Come on, ladies and gentlemen, once again, put your hands together. Come on. Now I request Mr. Vipin Garg to say a few words and put some light on industry insights and recognizing excellence and innovations. Can we all put your hands together for Mr. Vipin Garg? Come on.
We should do this? Okay.
A very good evening to all of you. I think I have to repeat again. A very good evening to all of you. Yeah, that's more like a noise of Metal Finishers Association of India. So I think first of all I would like to extend my sincere gratitude to the Metal Finisher Association of India for inviting me today on this occasion. Very honestly, it is really heartening for me to be here at this Indian Surface Finishing 2024 event with the esteemed surface coating veterans, lot of industry experts, chemical suppliers, and various research bodies associated with the surface finishing industry, not only from India, but also I'm very happy to see a lot of faces from the global team itself. In the past 3 days, I think all of us have witnessed exhibitions from various industries, along with conferences on advancements in surface finishing industry, showcasing about their potential and also their future growth story. I am sure that the shared knowledge and the innovative spirit which has been shared here will be very insightful for all of us. I think as we all know, surface finishing is a very crucial for any industry. Since I represent from an automobile company, I can very honestly and candidly say I have really seen a transformation in last 10 years at least. Particularly if we talk about automobile industry, for any attractive quality, we basically look for plush interior and sophisticated exterior looks. However, for enhancing performance, precision, and also long-term durability, we need to have well surface finish. This not only helps in prevention of corrosion, withstands wear and tear, and also improves the aerodynamics of a vehicle, all of which definitely extends the lifespan of a vehicle. All of us know that engine is the heart of the vehicle. Even in engine also, smooth surface finish of mating components enables less friction between parts, leading to better performance, fuel efficiency, and also longevity. We all know that India is aiming to become the third largest economy going forward in the world. The auto sector is one of the key pillars of India's growing economy. We at Maruti Suzuki are aiming to increase our annual production volumes from current 2 million to 4 million by 2030, almost doubling in the next 7 years. And we have a clear vision that we have to achieve this by achieving consistently zero defects products for our customers. This, I think, would be a huge opportunity for the entire industry to scale up their operations, benchmark the practices globally, and invest in technological advancements with the aim of improving quality without compromising on efficiency and cost effectiveness. Additionally, the rise of new technologies, particularly if I am talking about mobility sector, like electric vehicles, flex fuels, biofuels, and also now we are talking about hydrogen operated vehicles, presents new challenges and opportunities in the area of surface treatment. With emerging technologies, there is a possibility of increase in usage of certain base metals, particularly like tin, silver, and nickel. Also, in line with ever-increasing customer expectations for attractive aesthetic quality, use of various decorative coatings will definitely increase further. Now, if we talk about this event particularly, I think, as I mentioned earlier, we have witnessed cutting-edge advancements in surface treatment technologies, environment-friendly processes, and automation that promises to transform our approach towards surface finishing. Though I could devote some time today, so definitely for me also, I can honestly share there were a lot of learnings for me. Particularly, I think as we move ahead from various requirements, particularly about environment, like moving from current Hexa 6 to moving forward to Hexa 3. I'm sure going forward, these innovations will enable us to meet the stringent quality standards and address the upcoming challenges of carbon neutrality, circular economy, and also environmental concerns. I have one particular request which I'm sure all of you must be pursuing. But at a personal level, I strongly believe that as we move forward, all of us need to leverage digital technologies. so that we can work further towards moving on predictive quality, enhancing efficiencies and traceabilities throughout the process. I do feel that this important event of ISF 2024 will help all of us in propelling the growth of surface finishing industry and all other related activities. I am confident that the connection established and the knowledge shared during this event will lead to new partnerships, innovations and breakthroughs. Let us carry forward the momentum from these discussions. In the end, let me congratulate again the Metal Finishers Association of India for making this prestigious event a grand success. Very honestly, since I am attending this kind of event for the first time, I was positively surprised to see the response and the way technology is moving here. I would urge all of you to continue push the boundaries, and together let us shape a future where quality of our products reflects the spirit of our excellence and our actions reflect our promise for a greener tomorrow for the future generations. With this, I would like to close my address. Thank you all.
Thank you so much, sir. Now moving on to the award ceremony, I would like to request Mr. Vipin Garg to present the award to all the council members, for which I would like to call on stage Mr. Sunil Goyal, the President, Mr. Madhav Singh, the Trustee. Can we have a huge round of applause? Mr. Eknath S. Amin, the Trustee. Can we have a huge round of applause? Come on, everyone. Come on, everyone. Can we have a huge round of applause for Mr. Eknath S. Amin? Now I would like to call on stage Mr. Manmohan Kapoor, Vice President. Come on, everyone. Can we have a huge round of applause for Mr. Manmohan Kapoor? Next, I would like to call on stage Mr. Yashwant Patel, Vice President. Once again, a huge round of applause for Mr. Yashwant Patel. Next, I would like to invite Mr. Amit Agarwal, Honorable Secretary. Can we have a huge round of applause for Mr. Amit Agarwal? Next, I would like to call on stage Mr. Jayesh Shah, Joint Secretary. Can we have a huge round of applause for Mr. Jayesh Shah? Come on, everyone, put your hands together once again. Next, I would like to invite Mr. Nirmal Soni, Joint Treasurer. Come on, ladies and gentlemen, once again, put your hands together for Mr. Nirmal Soni. Next, I would like to call Mr. Praveen V. Menkar, the member. Can we have a huge round of applause once again? Come on, everyone, put your hands together. Next, I would like to call Mr. Kaushal Shah. Okay. Moving on, I would like to call on stage Mr. Ashok M. Sangvi, the member. Please put your hands together. Next, I would like to invite Mr. Anand Shah, the member. Please put your hands together for Mr. Anand Shah. Come on, ladies and gentlemen. Next, I would like to invite Mr. Hasmukh Jain, the member. Can we all give a huge round of applause for Mr. Hasmukh Jain? Come on, ladies and gentlemen. Now I would like to invite Mr. Babu Chindarkar. Can we all give a huge round of applause for Mr. Babu Chindarkar? Come on, ladies and gentlemen. Now moving on to the North India Council Member Awards, for which I would like to call on stage Mr. Ashu Bajaj, the President. Can we all put our hands together for Mr. Ashu Bajaj? Come on, ladies and gentlemen, put your hands together once again for Mr. Ashu Bajaj. Next, I would like to call Dr. Venkatesh Sundaram, the Secretary. Next. I would like to invite Mr. Chidambar Sharma, the Treasurer. Come on, everyone, put your hands together once again. Now I would like to call on stage Mr. Sunil Khanna, Joint Secretary, with a huge round of applause. Come on, everyone. Once again, ladies and gentlemen, put your hands together. Now I would like to invite on stage Mr. K.K. Kendra, Vice President. Can we give a huge round of applause for Mr. K.K. Kendra? Come on, ladies and gentlemen, once again put your hands together. Now I would like to invite Mr. Jagmohan Singh Bakshi, the member. Now I invite Mr. Ratan P. Khadana, the Vice President. Can we please give a huge round of applause? Next, I would like to invite Mr. Sanjeev Chauhan, the member. Come on, ladies and gentlemen, put your hands together for Mr. Sanjeev Chauhan. Next, I would like to invite Mr. Rajiv Joshi, the member. I would like to invite Mr. Varun Bansal. Can we have a huge round of applause for Mr. Varun Bansal? Come on, everyone. Come on, ladies and gentlemen, put your hands together once again for Mr. Varun Bansal. Next, I would like to call on stage Mr. Shashikant Chiller. Can we all put our hands together for Mr. Shashikant Chiller? Once again, ladies and gentlemen, put your hands together, come on. Now I would like to call on stage Mr. Satish Malhotra. Come on, ladies and gentlemen, put your hands together for Mr. Satish Malhotra.
सबसे पहले जिनका नाम अनाउंस हुआ था मिस्टर सुनील गोयल का और उनकी ट्रॉफी हम लोग ने रोक दी, तो अभी हम काउंसिल की तरफ से, विपिन जी माफ़ करिएगा, एक हमारी काउंसिल की तरफ से ये ट्रॉफी हम लोग उनको देना चाहेंगे, सिंस ये उनका लास्ट टेन्योर एज अ प्रेसिडेंट ऑफ MFAI, तो वो उनकी इच्छा थी कि इस बार जब हम यहाँ से निकले एज अ प्रेसिडेंट तो हमको हमारे काउंसिल फेलिसिटेट करे. सो आई वुड आस्क द काउंसिल टू कम डाउन एंड गिव हिम द ट्रॉफी. सर जिस तरफ यहाँ पे आप इधर आ जाइए, थोड़े लोग इधर जाएंगे, थोड़े लोग नीचे आएंगे. हाँ फ्रंट पे चलेगा, फ्रंट पे कोई
फ्रंट में थोड़ा आदमी को उधर से जाना पड़ेगा.
चलें जी, थोड़े लोग नीचे आ जाए. सुनील गोयल की ट्रॉफी किधर? वो उधर ही ऊपर ही है, वो है. चल दे दे. हाँ चलो.
Come on, ladies and gentlemen, put your hands together. Come on, everyone, put your hands together for Mr. Sunil Goyal. Come on. Service provider awards later.
हाँ तो अभी करिए.
Thank you so much, gentlemen. Now moving on to this. Now I would like to invite on stage Mr. Sanjeev Chauhan. Can we have you on stage, sir? Come on, ladies and gentlemen, put your hands together for Mr. Sanjeev Chauhan. Come on, everyone, put your hands together for Mr. Sanjeev Chauhan. Now moving on to the Service Provider Awards. I would like to call on stage Mr. Rajesh Naik. Can we have a huge round of applause for Mr. Rajesh Naik? Come on, everyone. Come on, everyone, put your hands together once again for Mr. Rajesh Naik. Now I would like to invite Mrs. Nikki Jain from Kanith, our digital service provider. Can we have anyone from Kanith? So this one is from Mrs. Nikki Jain from Kanith. Now I would like to invite on everyone, put your hands together once again. Now I would like to invite Mr. Abdul from IEML. Can we have anyone from IEML to receive the award? Now I request Mr. Sunil Goel to present the shawl to Mr. Vipin Garg. Come on everyone, put your hands together once again. Thank you so much everyone. Now I would like Mr. Amit Agarwal to take over.
It has been great, fun-filled and business-oriented 3 days from 14th to 16th of February. That is what the idea I got from the exhibitors. I think the visitors also got what they were looking for. It was nice to see a good crowd in the conference hall. And I cannot leave before thanking everyone who has contributed in a small or big way for this exhibition. Starting from the exhibitors, without which nothing can happen. If they don't come, you put up a very, very big show, and if they don't turn up, it's a damn squib. So thank you to the visitors. Next in line are the exhibitors who have done an excellent job this year. A gap of 7 years. They were thirsty, I think. A gap of 7 years, they were just waiting to showcase their products, and it was very vibrant during these 3 days. A whole lot of changes since 2017, and hope when we exhibit in 2028 it will be a grander operation. Thank you, sir. Now I thank all my colleagues who have worked relentlessly since the inception of 2024. The day we started, the day we started thinking of putting up an exhibition in 2024, after getting over the shock of 2020, where we have to reimburse every naya paisa, and we did that. But okay, we got over it and then announced 2024. Since then we have been working, and last 3 months have been very, very hectic. So I would like to thank my council for that, both Mumbai Council and North India chapter. We have been working as a team, and of course all the associations all over India have given their inputs to us in some way or the other. So I am grateful to them also. Thank you. Again, the conference this time has been very, very valuable. There were many repeated, there were very well known speakers which were there in 2017, but there were many new faces and many new speakers who shared their insights with us, which was very grateful. Thank you. Now, I would like, since we have invited a lot of corporate heads on the dais, and if Mr. Bachuvalli and Mr. Seduraman will excuse me, they had a time on stage. They have put on their views during the opening ceremony. So I would request these other three heads to say a few words. I would definitely start with Mr. Anuj Goenka to say a few words. And then we can continue in line. I don't have to introduce these tall words.
Hello friends, actually I had not thought what I would say, but it has been a super show. My team over here and all the visitors really appreciated the whole facilities and everything what was here. It was great exhibition. We had a very successful exhibition. Thank you everybody. Thank you so much. Thank you.
Good afternoon, ladies and gentlemen. My name is Manish Mehra. I have joined Government World recently, just 3 months ago, as Chief Operating Officer. And I would like to echo the sentiment which Mr. Amit said, that the exhibitors were waiting to showcase their products after a gap of 7 years. And it was, a big round of applause to MFAI for putting all that energy and getting all of us together. I think it was a wonderful thing. For me, it's the first time, but yes, I can see there is a lot which would have happened in these 7 years. What I could see while going around the show is there a lot of growth potential which is there in the industry, and which a lot of companies looking at India away from China. I think there are a lot of sectors which are coming up, semiconductors, electric vehicles, PV, solar. So I think there is a lot of newer areas which, and as you know, Mr. Amit said that some new topics were covered this time. I also listened to some of them. So apart from traditional chemistries, a lot of new areas are, they present a huge potential. And from a manufacturer side, I think quality would remain the prime focus. So how can we improve our products to reduce the defects at our end customers? Because I know in some segments still the defect rates are quite high. I think that would be one of the efforts. Then safety and environment, they are gaining a lot of attention, both due to international pressures as well as the statutory norms in India. So as manufacturers, it's our responsibility to keep working on those things. And as I see all the companies together, companies are there, dealers are there, I think there's a huge potential to collaborate. Of course, we are competitors, but I think in this industry, huge potential to collaborate and come together for the betterment of the industry and to grow together. I think there is room for everyone to grow in the coming years. Last but not the least, we would look forward to more diversity in the industry, because I see very few women in the room. I hope in the future there will be many more. Thank you so much.
Dear Mr. Vipin Garg, members of the Executive Council, my dear friends, it has been a wonderful experience during the last 3 years that we have put our hands together and exhibited our best possible technology and products. I will not speak much, but I can tell you, I can say one thing on behalf of my colleagues, my exhibitor friends, to Mr. Vipin Garg and the industry, कि हम हैं तैयार, आप हम बताइए हमें क्या करना है. Thank you very much.
since it has been a great success for ISF 2024. We would like to thank all our associate partners, CMF Consolidated Metal Finishing, ECT, Electrochem Technology Private Limited, and Global. Can we have a huge round of applause for our associate partners? Come on, ladies and gentlemen. Now I would like to invite Mr. Sunil Goyal, President of MFAI, to sum up this fantastic event and put some light on this remarkable journey of ISF 2024. Can we have a huge round of applause for Mr. Sunil Goyal? Come on.
Good evening, friends. Respected chief guest of today, Shri Vipin Garg ji, captains of the industry sitting in the dais, my colleagues from the council, exhibitors and participants. I have been given the job to sum up the ISF 2024. Dear friends, इतने बड़े इवेंट को इतने छोटे से टाइम पे समअप करना, शब्दों में बांधना बहुत मुश्किल है। और आज तो मेरे लिए एक सेंटिमेंटल दिन है कि आज मेरे को मेरी पूरी काउंसिल ने, ऑल द काउंसिल मेंबर हैज फेलिसिटेटेड मी। फ्रेंड्स, ये जज्बा आप लोग देख सकते हो कि मेरी काउंसिल, मेरी टीम मिलके मेरे को फेलिसिटेट कर रही है। मैं चाहूंगा इसी तरह सारा इवेंट, सारे एग्जीबिटर कंधे से कंधा मिला के चले तो इंडियन मेटल फिनिशिंग ग्लोबल मेटल फिनिशिंग को पूरी तरह से चैलेंज कर सकते हैं। हमारे चीफ गेस्ट सर ने कहा हम लोग थर्ड इकोनॉमी की तरफ, लार्जेस्ट इकोनॉमी की तरफ बढ़ रहे हैं, जो कि हमारे डियर प्राइम मिनिस्टर नरेंद्र दास मोदी जी का विजन है। तो हमारी इंडस्ट्री भी साथ साथ चल के ऑटोमोबाइल, टेक्सटाइल, डिफेंस सब सेक्टर के साथ मिलके कंधे से कंधा मिला के हरदम प्रयास करेंगे और करते रहेंगे कि हम लोग वो विजन जो हमारे प्राइम मिनिस्टर ने देखा है वो हम पूरा कर सके। ये नहीं हमारे लीडर बोल रहे हैं और हम लोग हाँ हाँ सुन लिया, नहीं, ये ट्रू स्पिरिट में है कि हम लोग उसको भी मिलके पूरा करेंगे। कमिंग टू ISF 2024, फ्रेंड्स, जब भी हमने ISF 2024 शुरू किया स्थिति बहुत खराब थी। आज से 2 साल पहले जैसे हम लोग बैठे हुए शायद एक साथ नहीं बैठ पा रहे थे। आदमी से आदमी घबरा रहा था, आदमी से आदमी डर रहा था। वो टाइम में हमारी टीम ने विजन लिया, नहीं इवेंट तो करना पड़ेगा चाहे जो हो। और वो दिन से जो मेरी टीम ने, हमारी टीम ने जो मिलके ये एफर्ट लिया और काम शुरू किया। आप सोच सकते हैं कि कोविड पीरियड के बाद तुरंत निकलना, फील्ड में जाना, और वो भी ऑनरेरी काम के लिए। Hats off to my team who has taken pain to make this event grand success. It is very easy to say than done, friends. बहुत easy है, हाँ इवेंट हो गया। लेकिन हमारे जो एग्जीबिटर्स हैं उन्होंने हमारी सोच से भी कहीं आगे जाके परफॉर्म किया। MFI ने सिर्फ प्लेटफॉर्म दिया, MFI ने सिर्फ एक जरिया दिया। शायद आप मुझसे सहमत होंगे कि जो स्टॉल्स लगे हैं वो बड़े बड़े इवेंट्स में भी इतने अच्छे स्टॉल्स नहीं लगते हैं। मैं भी बहुत जगह जाता हूं, तो मेरे सभी एग्जीबिटर्स के लिए जोरदार तालियां बजाई जाए। एग्जीबिशन के साथ हमारा नेक्स्ट एक पार्ट है कॉन्फ्रेंस। हरदम यही बोलते हैं कॉन्फ्रेंस में ये है वो है, समझ नहीं आता है। तो हमारे जो टेक्निकल हेड है मिस्टर जयेश शाह, उनको मैं कॉन्ग्रेचुलेट करूंगा। जयेश साहब थोड़ा सामने आइए ना सर। सर इनके लिए जरा जोरदार ताली बजाइए। इनकी और इन्होंने और इनकी टीम ने सर 43 लेक्चर्स, करेक्ट सर, 43 लेक्चर्स इन 2 days मोटा मोटा, क्योंकि फर्स्ट ओपनिंग हमने ले लिया और अभी क्लोजिंग भी हमने ले लिया, तो इनको हमने बहुत कम टाइम में, कम विंडो में उन्होंने वो 43 लेक्चर्स किए और सारे ऑल द लेक्चर्स वर वेरी गुड. आई हैव गॉन थ्रू ऑल ऑफ देम. आई वाज नॉट देयर इन कॉन्फ्रेंस रूम, बट आई कैन understand, I can study, I have seen those, I have studied those things. All lectures were absolutely very fine, highly technical. तो मेरा बहुत बहुत जयेश भाई से धन्यवाद है, और ऐसे ही जयेश भाई यू कीप ऑन डूइंग वर्क हार्ड. आपकी टीम के लिए बहुत 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 साधुवाद, बहुत बहुत धन्यवाद. जयेश भाई के साथ हमारे अशोक संघवी जी हैं, उन्होंने भी बहुत मेहनत से, बहुत हिम्मत से काम किया है. जब भी जयेश भाई को मैंने बोला था ना कि सर टेक्निकल, हमारा पहले टेक्निकल मैटर प्रोफेसर सीके मित्तल देखते थे, मैं उनको याद करना चाहूँगा, हम उनको गुरुजी बोलते थे. तो गुरुजी का एज हो गई तो ही टोल्ड मैं नहीं कर पाऊँगा. तो हमने हमारे जयेश सर को रिक्वेस्ट किया, सर ये आपको संभालना पड़ेगा. बोले गोयल साहब चाहते क्या हो, ये तो बहुत मुश्किल काम है, बड़े बहुत ज़्यादा सीनियर आदमी का काम है, मेरे जैसे यंग आदमी कैसे करेगा. बट समहाउ मैंने उनको रिक्वेस्ट किया, हमारी MFI की पूरी टीम ने रिक्वेस्ट किया, एंड ही परफॉर्म एज पर मच मोर देन दैट, मच मोर देन दैट. जयेश भाई, थैंक यू वंस अगेन, बिग थैंक यू. आई वुड लाइक टू थैंक कैनिथ, हमारी जो डिजिटल टीम है, उनको भी बहुत धन्यवाद करना चाहूँगा. आप देख रहे होंगे रोज लिंक्डइन में जुड़ा हुआ है लगातार, जो जुड़े हुए हैं. वी स्टार्टेड विद 0 लिंक्डइन टीम. कैन यू टेल हाउ मच वी हैव इन नाउ लिंक्डइन? वी स्टार्टेड विद 0, और हम लोग बोलते थे हम लोग क्यों ये काम कर रहे हैं, क्यों हम ऐड डाल रहे हैं, क्यों हम मैसेज दे रहे हैं. भाई साहब, कैन यू बिलीव, शुरू में 2-4 कोई भी फॉलोअर नहीं था, मतलब, और आज मेरे को लगता है वी हैव मोर देन 1000 फॉलोअर्स. ये एक डिजिटल वर्ल्ड के हिसाब से बहुत बड़ी सक्सेस है, 0 से 1000. आने वाले 2028 में मेरे को लगता है दिस फॉलोअरशिप शुड गो टू प्लस 10,000. कैन इट टीम, we expect this from you. So these are the few understanding. We had some lacunas in ISF. अपने इवेंट में कुछ ना कुछ कमियां रही हैं, वो हम उनको स्टडी करेंगे, आपका फीडबैक को नोट करेंगे, और आने वाली टीम को उसको we will forward it to them. They will study it and see to it that it should not be repeated. We'll see and try. ये हमने हरदम किया है, हरदम कोशिश की है कि हम जो हमारे कॉर्पोरेट्स बोलते हैं, जो हमारे एग्जीबिटर बोलते हैं, हम उसको फॉलो करें. तो हम लोग कोशिश करते हैं, फेल भी होते हैं, तो फेल होंगे तो क्या हुआ. हिम्मत, जिसको हिम्मत है उसकी हार कभी नहीं होती है. आज ये प्लेटफॉर्म से मैं सभी को बहुत बहुत धन्यवाद करता हूँ. IML, कैनेथ, ISML के जितने भी लोग लगे हुए हैं, हमारे पार्टी से मिस्टर राजेश नायक, ऑलवेज सामने आओ सर, सामने आने से पहचान मिलेगी, वरना कौन राजेश भाई, कोई नहीं है. राजेश नायक ये हमारे साथ लगातार तीसरा इवेंट कर रहे हैं, चौथा इवेंट कर रहे हैं लगातार. और नॉर्मल क्या होता है, 1-2 के बाद हर लोग छोड़ देते हैं, बोले यार जावा दो ना, लेकिन इन्होंने हमको कोई मौका नहीं दिया कि इनको हम डिसकंटिन्यू कर सके. और ये दोस्ती और ये रिलेशन, ये हमको लगता है आगे योर सपोर्ट. आज हम आप लोग से विदा लेंगे MFI, लेकिन ऐसा नहीं हम विदा लेके कहीं जा रहे हैं. वी विल बी हियर अगेन, आइदर इंडिया में ही रहेंगे, बॉम्बे रहे, दिल्ली रहे, चेन्नई रहे, बेंगलोर रहे. 2028 में इंटरनेशनल कांग्रेस हमको अलॉट हो चुकी है, IUSF अलॉट करती है, 15 साल 20 साल का वेटिंग रहती है. ISF ने हमको 2028 का अलॉट किया हुआ है, हमको दिया हुआ है स्लॉट, और उन्होंने पहले से अनाउंस करके रख दिया है। तो हम आपसे आज विदा लेंगे, सबको धन्यवाद करते हुए कि 2028 में एक बार फिर से मिलेंगे। आप सबका बहुत 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 धन्यवाद। धन्यवाद। With this address, I close this ISF 2024 close. Thank you, friends.
Now I request all the council members to be on the front for a group photo. Can we have you all on the front? So ladies and gentlemen, as I said earlier, it has been a fantastic and a fun-filling and business-oriented event. I would like to thank once again all the associate partners, CMF, ECT and Global. Can we have a huge round of applause once again, all the associate partners? Come on, ladies and gentlemen. Also, I would like to thank everyone once again for your remarkable presence and making this event a success. We'll definitely see you in the next ISF, which is in 2028. This is Dr. Azra Khan signing off. Thank you so much, everyone.
गाड़ी आएगी ना, हाँ, हम लोग करते हैं।